Okay, I think that's working. What's up, goobers? My normal microphone is back. I brought my my lapel mic kit to BattleBots a couple weekends ago, and I left it there by accident, so had to wait for it to get mailed back. So but it's back now, so I'm on my normal microphone now. So yeah, that's why the audio wasn't working for like 5 seconds, because I didn't change it yet. What's up, goopers? Yeah, I missed Sunday because I was feeling under the weather, and by under the weather, I actually mean I had a hangover. And but I'm good now. Okay, so what are we doing today? We're working on the Cradle of Pilth again. What is the Cradle of Pilth? The Cradle of Pilth is it's a thingy so that my AI assistant, who I cannot mention right now because if I say her name, then she will ask me stuff. I want to add a thing so that she can track, if I take my medications that day, because, especially my ADHD med, if I don't take it, then I'll be just, like, turbo distracted and not get anything, like, done. So, and I kind of want to add some stuff to, like, correlate, like, oh, you haven't gotten anything done in the past 7 hours. Did you even take your meds today? And I'm like, oh, no, I didn't. So, yeah, that's kind of what I want her to do. Adjusting my head a bit. Okay. I have no idea, but my mouth is, like, tired for some reason. So yeah, the Cradle of Pilth is supposed to track if I've taken my daily meds, and what else? I kind of want to gamify my taking medicine on time score, because it's fun, and when I get numbers, that makes me happy. Like, when Apple rolled out the sleep score for the Apple Watches, that has actually made me want to get better sleep, because it's like, oh no, you only got a 42 on your sleep score last night. You should go to bed earlier and stop waking up in the middle of the night. Or stuff like, oh, you got a 92 on your sleep score because you went to bed on time and you had a whole 25 hours of sleep. And, yeah, so I like gamified numbers. So if I could gamify, like, take my meds on time, that'd be pretty cool. But yeah, so last stream, we kind of did like an overall design of the Cradle of Pilth, at least the first version, and it has basically two main components. There's a thingy that tracks if the pill bottles are in where they're supposed to be. I guess if the pill bottles are home. So if they're not, it's implying that I'm taking it, and it would also yell at me if I have not put the pill bottles back. And this is just kind of like a carryover from when I had like an insulin dosing thing that I made for my diabetic cat. It needed to be refrigerated, like. So I had a thing where it would beep at me really loudly if the insulin was outside the fridge for like more than 10 minutes, so that we wouldn't spoil like a whole $100 vial of insulin for the kitty. Sleep schedule is hella important for real though. I am trying to get mine under control again. I've been fighting this battle for a while. Yeah, I have not had a stable sleep schedule since, like, honestly, high school, when I discovered that I could totally load anime on my old iPod Classic with the 320 by 240 pixel resolution screen, and I don't know how the hell I actually got through the entirety of like the first part of Naruto in like over 200 episodes of Bleach and like all of Haruhi and Ghost in the Shell and Lucky Star and like a bunch of other series. With subtitles on a 320 by 240 2-inch screen. I don't know how I did that, but in the late knots, I had to do what I had to do to sneak watching anime in bed while my parents think I was sleeping, instead of obviously sneaking out to go to parties and stuff. I was sneaking to get on the computer and watch anime and stuff. But yeah, so yeah, the overall design of the Cradle of Pilth. There are kind of two parts, and I think it probably makes sense for me to start streaming my iPad screen. So let me go get that set up. Doop, 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 doop. Okay, avatar view. Yeah, there we go. Okay. Yeah, that, well, actually, let me move this onto the other screen. Actually, what if oh, okay. And I need to change my screen resolution. I forgot to do that. Let me do that. I have like a shortcut set up on my Stream Deck to just change my ultra-wide screen resolution to just like 16:9 aspect ratio, so that like it doesn't distort on like when I'm streaming. It's really handy to do that. Anyway. Okay, so let's turn back on this thing. Don't know why it's looking crunchy again. It just does that sometimes, and then other times it looks normal. Actually, no, screw it. We're just gonna have it fit screen. Okay, close enough. Cool. Okay, so we had like kind of two parts of the Cradle of Pilth. The first one is a thing that yeah, this was the insulin tracker thing that I made for my cat. And this is what the pill bottle holder thing is based off of, where we just have a simple micro switch here, and the whenever the vial or the bottle is in there, then it just triggers it, tells the microcontroller, hey, the bottle's in here, and we're not gonna have this part. But this is what the old implementation had, where it had a screen on it too. This time it's gonna be talking to my AI assistant, who has a big, gigantic screen, so it doesn't need a separate screen. Although I might still add a beeper on it, just so that we got like really loud feedback sounds. And I have like 20 of those things, and we don't have to waste LLM power just to say, hey, put the pill bottle back where it should be. But yeah, so this part was really easy to design. There's nothing to really redesign here. If we go to if you go to the workbench, and then we look at this, okay, cool. My stuff is hidden. This is what we prototyped last stream, and it is super duper duper simple. We just have this ring shape, we just have this micro switch, and pill bottles slide in here. We found out last stream that there's like, where did I put it? Here it was. Yeah, found out that there's a bunch of standard pill bottle sizes that only vary by like a meter or a millimeter or so. Not these small ones, but like, and then I actually found that the Amazon bottles, let me just hold it properly so I don't show personal details, I guess. Yeah. Are also gonna be the same diameter. So there is a standard pill bottle size. And these Amazon pharmacy ones, they fit within that, I guess, that size range. So, yeah, we don't really have to worry about that, and if I get, like, a weird pill bottle that doesn't fit, I can just transfer it into one of the standard bottles. I have, like, so many of those, just since you get a new one every month. That's weird. Why is my face lagging a bit? Well, anyway, now, the second part, though, this is the part that was taking a while to design last stream. Oh, wait, I forgot to show also. So, yeah, after making the single version and just making sure that it all fits, just scaled it up to 4 of them, and there were some slight adjustments that I made last stream. We made this overall design, but what I changed since last stream was I actually rotated these parts 45 degrees, because before all of them were aligned like this. but that would actually make it really difficult to access the screws. So now that they're rotated by 45 degrees, the screws are just accessed by this way. And you don't have to like fight like weird angles trying to get in like this. So yeah, that means that the micro switches are offset to those diagonals. It's a little more space efficient, I think. And we have these slight chamfers here, just make it a little bit easier to guide in. Haven't decided yet, because it might compromise some of the strength, but I might cut some notches in here, because we don't need it to like hold the entire thing in a complete circle to hold it. We can just have like a C shape, and then it'll be easier to remove and stuff. But yeah, you can fit up to 4 pill bottles in here. Realistically, I think I only need one of these active most of the time, and that's for my ADHD meds, which cannot be packaged with the pill pack stuff because it's a controlled substance, but everything else kind of lives in the pill pack. So those 3 extra slots are just in case and I get some random thing added to it, or if I have a new prescription and they're sending me like a little, I forgot what they call it, but it's like a little holdover bottle until they can put it in with my pill pack, since the pill packs are made like every month. And if they want me to start something like ASAP, then yeah. And then what else? So the thing that's gonna be that I want to redesign though is the thing that holds the pill pack stuff. And let me go get the pill pack stuff to show what it is. Huh. Oh, cool! They added fiber to it. Awesome. I forgot if I added fiber supplement to my pill pack. Okay, let me just make sure this doesn't have docks. Okay, cool, it doesn't have docks. Okay, so this is a pill pack. All my medications are like separated out like per day or per time of day. And yeah. So it's just a long tapeworm of medications that are all individually packaged for each dosage time. And it's really convenient, but it's also kind of hard to make a thing kind of like the bottle holder for it. So yeah, it's the first design that I was thinking of doing was like having kind of like a spool shape that this would wrap around, and then like inserting the tail end of it into this middle part here, and then tracking the rotations. But I realized that's actually gonna be a pain in the ass to do every month. And it was also gonna cost a lot of filament, and I also totally fucked this one up because the support material doesn't even want to come off of this PLA. So yeah, I think I'm abandoning this design. And what I want to do instead is, use 2 rollers, I think, with, the pill pack things, just kind of going through it. And then, one of the rollers would just be passive, and the other one would actually have, rotation sensor on it, which would probably just be a Hall effect magnet encoder thing, just like we were planning to use on the spool. And this would have some advantages. First one is, no matter how big or small the pill pack gets, we don't have to worry about it kind of outgrowing the size of it, and you don't need to spend a bunch of filament 3D printing enclosure for it, and you don't have to worry about the kinematics. Is kinematics the right word? I guess we don't have to worry about just the motion of having this entire spool thing rotate around and stuff, and things getting caught in it or whatever, because like the way that the pill pack's box works, let me take off personal information from it. Okay, I didn't quite get rid of all of that. Let me just scratch it out with Sharpie. somehow it's still getting through the Sharpie. That's weird. Okay, let me just put like some metallic Sharpie on top of the black Sharpie. Ah, yeah, that works well. Okay, cool. So yeah, with the pill pack, it already came this like kind of roll thingy, just repackaged like this, and it just kind of sits in this little box thing. And so if we can avoid having to make like this massive spool kind of bullshit, just and like just have like kind of two rollers like go in between here, and just kind of intercept it, then that would be I think that would be more efficient, I guess. We could print that faster, we could iterate faster, we'd waste less plastic trying to iterate on this, and yeah. Now, there are a couple things that do make it a little bit difficult, but not terribly difficult. First one is we have all these different pills of different sizes, so that doesn't really roll that smoothly, and the solution for that, I think, is we have the Harbor Freight $5 pack of random assorted springs, and it has both compressy springs and whatever the opposite of them are called, compression and extension springs. Okay, so yeah, we can just have kind of two rollers with like these springs, just to like kind of keep them clamped together, so that we have some pressure applied, so that we have the friction needed to spin the rollers, and so that we can also kind of get it no matter how thin or thick the pills and the stack of them are. So yeah, we have this thing. We have so many of these different things. We have so many that we can definitely play around with different sizes and strengths of it. Yeah, springs are fun. But yeah, this pack of springs is like literally $5 at Harbor Freight. Yeah, I got all my stuff at the pillbox over 20 minutes away. I get my ADHD meds at my grocery store, which are like 5 minutes away. And the pill pack comes in the mail. But yeah, I'm very forgetful. So the more I can automate it, the easier it is for me. Okay, let's see. Oh yeah, the second part. Let's see, is my robot around here, or at least a wheel or something? I have some wheels. Okay, so, yeah, the second part, though, that makes this a little bit tricky, is, the rollers. Now, there is TPU filament, which is kind of soft and kind of rubbery, but let's be honest, it is not very frictiony at all. It's not very soft. It's, 95, Shore A scale, I think, is the flexibility of it, and, I'm not sure I think softness is the correct word for it. So yeah, we could use TPU, but honestly, this stuff is, like, super frictiony. Like, if you're using TPU for, like, wheels or anything, that's just not a good idea for, like, tires, because it has, like, no grip. It might work if you're doing something like off-road stuff, with like a rock crawler or something, and it's gonna be more about the shape of your tires on the dirt and grabbing stuff. But if you're just trying to like get stuff on like a slick surface or a smooth surface, it's not gonna cut it. Now the good thing though is that there are ways around it. We can mold our own tires, and it's very easy, especially if you use certain materials like Vitaflex, which do not require a vacuum chamber and are relatively low toxicity. Like, you still shouldn't like drink it or something, but you can use it at home without worrying about like getting super cancer or something. And I've been making my robot wheels out of this stuff since I started building combat robots, and it is super duper grippy. It's easier to work with than like silicone, because you don't need like a vacuum chamber or anything for that. It just kind of settles itself and gets rid of the air, or at least enough air, automatically. You can work with that just room temperature. But yeah, it's really easy stuff to work with. You can mix in dyes, pigment powders, and stuff like that. I use mica or mica powder, I don't know how it's pronounced, to make mine purple. But yeah, and so what this beat-up box is, thank you FedEx for that delivery. That there's some sarcasm in that, but it's okay because this stuff is generally protected from it. It is more Vitaflex, because one downside of it is that the Vitaflex does kind of expire if you, for like a few months after opening it. It just hardens, and you can't use it anymore because it just hardened inside the bottle. So I had to throw away last year's supply and get a new set of it. But yeah. So here's the stuff. Vitaflex comes in several different harnesses, and this one is Shore 30A hardness. This is the one that I use for most of my robot stuff. Let's see, it has some of the most aggressive packaging. It's great. Like, what are you waiting for? Make it now! But yeah. I wonder if they still have, like, the old social media on it, because I noticed that this had, like, not only did it say Twitter on it, which, fuck calling it X, I'm calling it Twitter forever anyway, but, like, it didn't just say Twitter on it, it had, like, the old logo for Twitter that got, like, decommissioned, like, several years ago, so it'd be funny if they still have it, like, on here. I don't know if the trial sizes have it, but I remember seeing it on some packaging recently. It may have been at BattleBots, actually, with, like, the bigger packages. Oh, there's a YouTube logo here. I think that may be one of their older ones. I don't know if they still use that one. I don't see it. But yeah, this stuff is pretty easy to use. You just, mix equal parts of it, and to enforce equality, I like to actually use a small scale from it. Not this one. This one's not precise enough. I have, like, a scale that does, like, 0.1 gram increments, I think, but... Ah, here it is. Yeah, so I like to use this kind of scale for, like, epoxy and, Vitaflex and stuff like that. But yeah. Now, I did mention the thing about the, yeah, it's really similar to silicone. Like, it's just two-part mix. I think that... Okay, I'm not sure if silicone is technically a urethane, but this stuff is definitely a urethane. And it works very, very similarly. The only difference, really, is I don't think this stuff is food safe, so don't use it to make any toys. And, it's, you need the vacuum chamber for silicone to come out decent at all, I think. Well, the Vitaflex you don't. I don't know what the price difference is. I think Vitaflex is slightly more expensive, but then you get to save money on not buying that vacuum chamber, so I guess it works out. But yeah, so I mentioned that Vitaflex has the problem of once you open it up, it just kind of hardens up after like a few months and you can't use it anymore, and that's what I got this for. This is Argon. It's a brand name of just compressed argon gas. Argon is a noble gas. It does not react with anything, at least under normal conditions. I wouldn't be surprised if there's like some weird like fusion or fission or some bullshit, whatever, to get it to react or turn into plasma. I don't know. But, yeah, so argon gas, it doesn't react with anything under normal conditions, and, it's heavier than normal air. So when you open up the bottle of, Vitaflex, or whatever it is, then you can just spray a couple puffs of that in there, and it will displace the normal air, the oxygen, and hopefully the moisture too, and, just replace it with an inert gas, and it should extend the lifespan of it a lot longer. And so, yeah, this stuff, you can also, it's actually meant for foods, I think, primarily. Yeah, like, on here it says, preserve coffee, wine, herbs, food, and much more, but I'm using it for, industrial chemicals. Let me go also turn on the rest of the lights here, because, like, I realize that we're getting a weird light gradient with, like, both the workbench light, and the ceiling lights being off. But anyway, so, yeah. You can actually get kind of cheaper version of this stuff that uses, I think, mainly nitrogen, which is not a noble gas. It's not inert, so it will still react, but it'll react with a lot less stuff than, like, oxygen, I guess. So yeah, you can get similar stuff for a bit cheaper, to, preserve, like, wines and, foods and stuff, but argon is gonna be better for, like, I guess it's just less reactive chemically, so, it should last a bit longer with using argon. But yeah. Okay. So, yeah. So what are we doing then? I guess that we're gonna be designing a thing so that we can get those rollers working. And the molds also for the rollers. So, and let's see, I think I want to be able to 3D print at least the roller thingies and their molds so that I can show the molding process and just get that done overnight so it's ready by Thursday, because Vitaflex only takes 24 hours to cure, and you can actually add an additive called Kick It, which I think shortens it to like 12 hours, which is actually how you can mold and have fully ready wheels at BattleBots in less than a day. So yeah, it's very easy to work with. It's why it's extremely popular in the combat robotics community for making custom wheels, just because you just don't need any special equipment for it. You just need to be able to measure two equal sizes, mix it for 3 to 5 minutes, get it into whatever mold you need by the time it hardens, which the pot life is, I think, 10 to 15 minutes, and then just wait 24 hours and you're good. Okay. So yeah, I guess the first thing then is, let's see, let's actually kind of just sketch out the overall design of what we need, and then, you can list out what the different parts are, and then we can start CADing them. Bless me. With the first parts being the spline, for the rollers, as well as the, what's it called? The molds, so that we can start to get the Vitaflex stuff, and then we can design the rest of the mechanism and start 3D printing that, and I think that will be the stream. That should be maybe about 3-ish, 4-ish hours of stuff to do. Okay, cool. So the first part is we need to do the rollers, and the rollers are going to be basically the exact same thing as these wheels, except for instead of them being like thin, they're going to be very wide enough to let the pillpack stuff go through it. And just because there's nothing like really special going on with it, I don't think we need to get like too funky with the shapes on that. Although I still might get funky with it just because it's fun. But yeah, so we're gonna need like a central core, I guess, for the roller, and it will need to have retaining features, which I'll just kind of show as these little things, but there's so many ways to make retaining features. There actually is one that I have not tried before that I might try, just to try it out. If it's compatible with the design I'm thinking of anyway, which is using a gyroid pattern and letting it fill that in. So we're gonna need like 2 rollers. And I don't know if both of them actually need to be molded, or if we only need one of them to be like nice and rubbery and the other one can just be passive. I mean, there's not really a point in me showing the process twice, so I could just prototype and have like 2 of them or have just one of them be like just straight up TPU or PLA and the other one actually being like molded around or something. We can figure that out. We might not even need 2 rollers. We could actually just get away with like 1 roller and like have the other one just be like very low friction thing. You know, actually, let's try that at first, because that's going to result in a simpler mechanism. Is this eraser? Yeah. That'll actually result in a simpler mechanism at first, and if we need the roller, then we can just add that on. And so I'm just going to get a little bit funky with the shape here. We're just going to go with like maybe something kind of like stacked cones, I guess, kind of like if shark teeth were like cylindrical. Yeah, something like that. And so we're gonna have just a dead shaft here, and honestly that'll probably just be a shoulder bolt. Or a partially threaded bolt even. It doesn't even need to be like super high tolerance. I have several bearings I can figure out one that actually fits that pretty well. And then the second part is gonna be a little bit tougher. It'll probably need to have like something kind of like this out here, and then kind of a way to retain it in here, and then like we need to find a way to hold the Hall effect encoder stuff, and then yeah, and that actually might need to stick out now I think about it, because yeah, so that might need to stick out here, and let's add some springs here that are constantly pulling it down against. We're just gonna have a really simple surface here first, and then we'll see if we actually need that to be another roller also. I don't think it does need to, but we might need to. That's what rapid prototyping's for. And then here we would actually attach the magnet, and then so yeah, we'll attach the magnet here, and then we'll have the Hall effect encoder here, and then we need some kind of a retaining thing so that Hall effect encoder can be always in axis with the roller, and then yeah, we'll just have the pillpack thing just kind of roll through this. And so, what, oh yeah, I guess that needs some kind of like a, yeah, I think that just keep things simple. We're just gonna need like a hinge kind of mechanism here. It's like just gonna be like pseudo-perspective-ish stuff in this drawing. So, what do we need then? I'm gonna do like a little side view of this, I guess. So, let's assume that all we need is just a plate here. So then we have our roller here, and then we have a lever-y thing here, and then we have our spring to keep that pushed up against it, and then we have the pill pack thing with all the little pills here. You can pull through that. Yeah. So what does that need then? We need the, why am I numbering these? Just need to dash them. Okay, we need the roller center, and then we need the roller mold, which is not going to be actually a part of the design, but it's going to be used to help make it. We need side 1 hinge, passive, side 2 hinge with encoder, and then we need the, we'll just call that the base. And yeah, we already have the springs, so that's nice, and if for some reason those springs don't work and need something even stronger, we have a bunch of O-rings, and O-rings can be used kind of also as like elastic in that sense. Although I prefer to use the springs because springs are metal, and metal is cool. Okay, what else? Okay, so the Cradle of Pilth is, what's the pill box for? it's, I basically just want a way for, my AI assistant to track if I've taken my medicine for the day. Because, like, yeah, it's good to stay healthy, but also because one of those meds is, my ADHD meds. So if I don't take them, then I'm just, like, going, wee! And I'm just, like, not concentrating and stuff. So, yeah, I want her to be able to correlate, you haven't been doing anything for the past 5 hours except play League of Legends and eat chicken nuggets. Have you even taken your meds? And I'm like, no. And instead of that, she'll just be like, you have not taken your meds, and that is why you have only played League of Legends and eaten chicken nuggets. Go take your meds now. And I'm like, okay. So yeah, that's kind of what she's for. Or part of what she's for. I mean, she does a lot of important things, but, this will be an add-on for her to track if I've taken my meds. Okay, yeah, so, it makes sense, I think, to design the roller center and the roller mold first. So that we can get that printed, and I can show the, molding process, towards the end of the stream, I think. So, I guess first thing, where are my calipers? Okay, I got my calipers. Alright, so I think we took these measurements before, but I'll have to take them again. The roller will need to accommodate at least 69, nice. Let's round it up to maybe 80 millimeters, just so that we don't have to get this like exactly lined up and you have some wiggle room. Actually, what's the width of this? Because this is the box that it comes with by default, 75 millimeters. So if the box comes in like 75 millimeters by default, I think that's kind of a healthy amount of wiggle room that we can kind of estimate for this. No, it's I have thought about that, but that seems like more work for me to figure out. I have seen projects though for like an auto dispenser, but in this case, she would just track if I have pulled out my medications, because this is a pillpack. It used to be standalone, then it was bought by Amazon Pharmacy, which is kind of crazy that Amazon has like all these different divisions now. But anyway. So, yeah, they just pre-package, like, all the medications and, like, medications and supplements in just, like, daily dosage form factor. And it's really convenient, especially if you have, like, lots of stuff to take, so you don't have to be like, okay, did I take every single one, or did I miss a bottle or something? But yeah, the one thing, though, that I can't get in there is my ADHD meds, which is why we have, this thing here, which is just 4 of these guys put together, which just holds 4 pill bottles. Plus I wanted extra slots, because right now I actually have like 2 of these bottles I need to take, just because one of those ADHD meds, and the other one is a supplement that got added to this one, but it wasn't there yet, so they sent me like a little, I forgot what they call it, but like just kind of like a carryover bottle until they could move it into the pill pack. But, like, I kind of figured I want, like, 3 extra slots in case the doctor's like, oh, no, you're, you have ligma, and you need to take this for a month. I'm like, ah, darn, I have ligma. So they'll prescribe me, like, my ligma medicine, and I'll just have it in there and be like, okay, assistant, I have to take my ligma medicine every 12 hours. But, yeah. So yeah, that's what it's for. The thing that tracks the bottle thing, at least the physical design of it, that was a very easy problem to solve. So yeah, we're not gonna be worrying about that one today because it already works. My chair got messed up, or not my chair, my carpet under the chair. So I was fixing it. Anyway, so yeah, we have this. It works. Just a simple micro switch. So we have 4 of these now. We can solve the micro switches real easily into here, and programming for this is super simple since it's literally just a switch. So the part that we're redoing today is, instead of having everything on a giant spool for the pill pack, we're moving everything to rollers so that it can scale better. Yeah. So let's get the No, I don't want it from that side, actually. Let's design the roller first with the retaining features. And I'm thinking that just so that we don't have to, like, reprint and remold every time, I'm thinking that, like, the axle and, like, all the embedded shit, we're just not going to worry about that right now. We'll probably just have, like, I think that we should just have a hollow roller only, and then we should add some keying features, and then we can make the spline, we should, not spline, we should make kind of a shaft for it that, we can swap out easily. And with that, we can probably just add some keying features and, like, maybe just a couple of rub screws. It doesn't need, like, super high precision. We're just letting some pills in a pack thingy, pass through it. But, okay. So, let's start with the center line, and let's make that, I want 75 millimeters, because that is what the width of the box is. So that's an acceptable amount of wiggle room, I think. And then for a central shaft, I think that probably 8 millimeters ish is probably reasonable. Yeah, I think 8 millimeters is probably reasonable. Amount of space for that. Actually, let's make it 10, just in case the keying features get a bit wacky. Because I'm not really too concerned about being efficient with the Vitaflex here. And then let's set those to construction. And then I think that, yeah, so the roller itself is actually just going to be pretty simple. It's basically just going to be a cylinder with some retaining features so that the Vitaflex just kind of goes and stays anchored with it. And we can make this another 5 millimeters, which means that the overall diameter of this will be, okay, so that's 10, so then let's say that we have like about maybe 5-ish. I think we're looking at 30 millimeters. That's not bad. I think this wheel is actually literally 30 millimeters, so it's not going to be that, it's not going to be too big. It's not going to use too much Vitaflex anyway. But yeah. And then the retaining features. I don't think I want to do the new one. I think I just want to stick to what I know here right now. Okay. I actually forgot that one thing that I like that Fusion 360 does that I don't think SolidWorks does this is you can actually do patterns that are symmetric across a line instead of only like going in a single direction, and that is really convenient. So right now I'm making the retaining features for this, and so what it's going to be is like we're going to have a bunch of like channels that go throughout the entire thing, and then we're going to have some like exit windows, and then we're going to just kind of revolve those, I guess, in a pattern, and then we'll have the Vitaflex be able to just kind of loop into it a lot. So let's create a rectangular pattern, objects, direction, that direction, yeah. And then we can make it symmetric. And we'll just spam random numbers until we have something that looks like it works. And that looks like it works to me. You know, I actually forgot. Nah, we don't need that. Okay. So, we'll take this. We will take that profile. And revolve it. Why did it pre-select that one axis? I didn't want to do that. is really weird. What if you just make that like a construction line instead of center line? There we go. That was the issue. Okay, so you have all these channels, but they're not connected to anything. So we're gonna go back to this sketch. No, actually, let's not do that. Let's just make a new sketch, I guess. No, actually, yeah. Let's go back and edit the sketch. You know, actually, let's... I think I did something in the wrong order. Let's actually add those channels in there too right now. Okay, and then let's make the pattern. So the objects are going to be these, and the direction is going to be that direction, and like what, 9 of these, I think? 9 symmetric, and I think distance was 33? Yeah. Okay, cool. So I think what I'm actually going to do here is axis is going to be that, profile is going to be this. Did I forget to turn that one back into a, yeah, that should have been construction, not center line. Okay, try again. There we go. So let's make that, yeah, let's just make that 360. And then let's take this and just do, why can't I select multiple oh, I guess I can if I hold control, which I don't remember the rest of the app working like this, but okay. I'm gonna do that, but instead of 360, we're gonna do like 10 degrees. 10 might be too small. We'll just go with, I don't know, 30 degrees, and let's have it be symmetric. Or I guess 15 degrees, since it's symmetric. So we have that. And then we're just going to, where is it? Circular pattern, I think? For features, this along that axis. And we're just gonna, no, let's try 6 at first. 6 looks good. Cool. So yeah, this is how we're going to have our rollers retain the vital flex to it. Yeah, that seems pretty good, I think. And then, let's see, we need the mold after that. How am I gonna do the mold? I think I'm gonna start 3D printing this first, just so that, oh no, we need the keying features. Yeah, let's just add the keying features here. Okay, so cool. So you have that, and I think the keying features, I don't need to go like super hardcore on it. Let's just make it a hexagon. I like hexagons. Easy. Let's make that tangent. Yeah, let's just do a hexagon. This is not robot combat. This is not gonna be high stress impact shit. You don't need to get like super hardcore on it. Let's just do a hexagon. Okay, we have hexagon. Alright, awesome. I probably want to add a couple grub screw things just so that we can be able to like hold it in there. What's the easiest way to do this? I think the easiest way to do this would be, yeah, let's just, solidify, I guess. Wait, no. Do we actually need it? I'm just trying to think of, like, how I'm going to secure this so it doesn't, like, move back and forth, like, along... Oh! I have not even been showing the CAD stuff the whole time? Okay. Now I'm showing the CAD stuff. Wow. Okay, so, what I was doing is that I made this pattern, and, we just revolved it around here. And then we got, like, this kind of, like, stack of stuff with all these channels, and then we added one of these things here so that, we can actually have, like, loops of, the urethane being, like, looped around it so it doesn't fall off. And then we just did a pattern of that. And then what did we do here? I think this is where I just, added the hexagon keying feature. And then somewhere here, I think I just had a sketch here that I was thinking about, but decided not to actually use. So I'm just thinking about how I'm going to secure whatever shaft is on here. I don't want to rely on a friction or adhesives. So I think I'm just going to do like a really simple grub screw thing going on. Just trying to figure out where I want to insert that. But honestly, I think I'm overthinking it. And we don't need continuous channels throughout the whole entire thing, because those are just retaining features anyway. So let's see, this is a solid part. So I'm thinking that we just do I'm just trying to get the pattern in there. So I'm thinking that we just have a couple of these things going on. So we're just gonna not have the retaining feature go there. And then that's going to be where we position our grub screws, and we'll just mirror that feature. Construction line. I don't really expect this to be getting a ton of usage, so I'm just wondering if we can just put what's it called? Threaded inserts in here. That's not a problem. Or even better, we could just put threaded inserts into the shaft itself, I think. And then we don't have to worry about retaining features or we don't have to worry about having the threaded inserts in the rollers, which itself would be kind of a pain in the ass. So we'll just do 4.5 here. Oh wow, that is thinner than I expected. Maybe it needs to be M3 instead of M4. Let's do M3 instead. Okay, cool. So let's just take that and two sides through all and through all. And then we can just put screws in through here, and then the shaft itself will have a threaded insert so that we can just put the screw in here, so that should keep it locked in there. And we will just replicate that on the other side. So we'll make a mid-plane thread, not thread, mid-plane, plane, something, plane there. And then we will mirror those features. So I think it was, that feature and that feature. Yeah. Okay, cool. So we have that. Okay, cool. Let's call this roller, up. Okay. So, let's get this printed. And I'm trying to think if this needs to be... I think this can just be PLA. I don't think there's any reason this needs to be, like, anything crazy. So, let's do that. And let me go get my, filaments loaded. What filaments do I have that I don't have to dig for? I do have a bit of black filament. There... PTG, ABS, TPU, or TPU. I mean, honestly, I might just use TPU so I can use up all this TPU. Yeah, let's just use TPU, why not? Okay. So, just gonna unload that. Do I want to use TPU? No, I want to use, I'm gonna use PLA. I guess I have to go find my other PLA then, which I think I hid away. Because this one roll that I have loaded is, almost empty. Okay, cool. I have plenty of PLA, that's not a problem. Wow, yeah. It's gonna be like random colors. That's okay. Alright, so how long is this gonna take to print if we just do generic PLA? Wow, that's not bad. Only 14 minutes. Don't think this needs any supports. We don't really care that much about the interior structure being like super accurate because it's literally just gonna be flooded with the urethane. So yeah, let's do that. Do we even have anything with infill in here, or is it all just basically solid? We have a tiny bit of infill. And we might as well just make it all solid. Let's just blast that up to like 8 walls. There, fully solid print. Okay, cool. So let's just add a brim just to keep it stable, since it's a pretty tall print. And yeah, we'll print that. Okay. Ooh, hydrate. Oh, hydrate's not gonna work because the cup, I think the thing just kind of failed overnight with like, the power failed, so it rebooted with the cup on it. But, okay, now the hydration thing should work. You can try again. Okay, the bamboo is going. And we can do the roller mold now. So the mold is interesting because you kind of just want like a negative of what you're making, I guess. So yeah, let's have that. Let's offset this by like negative 0.1, or no, by 0.1, I guess. we can have this go up. It doesn't have to go all the way. Maybe negative 20 is probably okay. And then let's also take that. Let's have it be like 0.1 there. And then here, I'm just gonna make this a lot larger than it needs to be, just so that we can just trim away the excess. Let's make that negative 3-ish. Oop. Okay, there's an ad break. Okay, so I'm gonna go get a. Oh no, I have Monster in my fridge. Okay. I'm gonna go look up how long Twitch ads are. Is a Twitch ad break. Minutes. Okay, I'll just set a timer for like 1.5 minutes then. Set timer for 1.5 minutes.
1 minute and 30 seconds.
And my Apple Watch needs to charge anyway. I'm just taking a little break while the ad rolls on Twitch. I really need to set up a bot for that. I keep forgetting to do that. Pet the kitty. JJ, you're being nice today. You're actually sitting on the futon instead of on the high traffic area. You're not being stepped on. That's good. You should learn to sit here more. He's a good kitty. Oh, okay. I'm gonna assume that the ad break is done. Okay, so, what was I doing? We got the 3D print started, and, so we have our roller hub here, and, now we're just making the mold for it. And so, the way that I'm gonna do it is we're gonna just have it, like, kind of poured in through the side. And here, I'm just gonna find where that is and just drill it out when it's time to actually process it, I guess. Might need to freeze it so that we can drill through the Vitaflex, or I might just actually put in like some dummy screws so that I can just take that out. I don't know. I'll figure it out. Actually, to make it align easier, it might be easy if we just have like some screw holes in the mold to align that and we just pull it out, but yeah, we can figure that out. Anyway, so yeah, we have this stuff, and, we have a base here, because it's going to be standing like this, and the idea is we're going to do another revolve, bless me, to do the shape of this thing. So, yeah. Let's just, add some lines. lines weren't actually aligned. But okay. So yeah, that center line. Actually, let's make all of these not center lines, construction lines. Okay, so I'm just gonna line that up to here. Also make that one a construction line. And then line this one up to here. And this one is also gonna be a construction line, I think. Coincident. Okay, so I'm thinking that the minimum thickness of that should be like 3 millimeters, and then the maximum here should probably be like, no, that's actually kind of too much variance. Let's go with like 4 millimeters, I guess. What is that radius going to be though? 17. It's 34. I don't like that number. Let's go with 36. Okay, 36. So, I think here, you know, actually I think it might be better if we just go this way, I think. It's gonna be a little bit, it's gonna be kind of evenish, but not perfectly even. Oh, wait. Doop, 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 doop. No, that's not gonna work the way I thought it would. Well, you know, these things don't actually have to line up with that, so let's... Let's just have it be like 5-pointed-ish, I guess. And then we'll just make all these lines even. And hopefully that won't cause a disaster, although there's a good chance that it will. Yep, it didn't like that. Let's maybe just go one at a time. Okay, that's actually not so mad. There we go. Okay, there. So, yeah, I want the mold to have, like, that kind of shape. Let's make it so that the mold at thinnest is, like, gonna be 3 millimeters here. Yeah. We'll just make sure that actually touches the bottom of this, because there is a 1 millimeter gap here, or 0.1 millimeter gap. Just for, like, printing tolerances. Okay, so that axis is there, and we can make it a full 360. And let's just make sure that the bodies are separate. We have the roller body here, and we have the mold body here. And let's just get rid of that. Okay. Now, there is one obvious problem here. If we mold that in there with the central hub in there, then we can't pull it out because it's got all these, like, ridges and stuff. So, we need to split this in half. Thankfully that's easy. Wait, is it as easy as I think it is? That should be. How do I want to do that? Because the one part that does complicate this a bit is that we have that base also. What I'm thinking is, instead of splitting it in half, we'll have it split into 3 parts. We'll have, like, the bottom base part, and then we'll have the sides. Yeah, I don't think that's gonna be bad. And then let's actually extrude this up, like, maybe just, like, 2. ish, just so that we can kind of get like a thingy going there. Okay, and I guess here instead of 3, let's maybe make that 5, I guess. So what I'm thinking is we're going to have it split up here. 0.1. And then we're going to exclude that so that we have 3 parts now. We have this roller, and then we have the bottom of the mold, and this will sit down in here. And then we have this top part of the mold, and then we split the top part of the mold in half. Although, let's also add some features so that we can clamp it together. Center rectangle. Let's make that like, I don't know, just maybe 8 millimeters. This here can be like 60 millimeters, I guess. And then we'll have that go down here. And then we will take a mid-plane. What? Okay. That's easy. And then we will split this in half. Where's the split tool? There. Although, let's not do that yet. Let's add some holes. So, we're going to be able to clamp it together with some screws. And we don't need that many, especially because we're going to be using, what's it called, petroleum jelly to act as both the mold release and like kind of a mold seal, so that stuff doesn't really get through all little cracks. Yeah, I think that's reasonable. Is that even? Okay, there. Let's just make that like 10 or so. And let's make all these even. Or equal. And let's just do 4 screws. Okay, cool. And then, let me go get my, I should have, like, some square nuts around here, yeah. Square nut? No, that's not a square nut. This one's a square nut. And I think that's M4? Yeah, that's M4. Okay, so I should really have this on a chart. That's gonna be, let's just make that 7.2 millimeters. And let's do, let's do, center rectangles, no. I wish that I had, like, a way to do, like, center rectangle, but, like, not aligned, like, horizontally. Or I guess not aligned, like, orthogonally, I guess, instead of having, like, delete these things. Oh, you know, actually, I might be able to do that if I just do, like, a 4-sided polygon, I think. That's 6-sided. How do I get it so that, what's up? I'm making the Cradle of Pilth. Okay, edge number 4. There we go. That's what I wanted. And I think this is the first time. Why did it not stay being 4? Okay, you know what? I'm overcomplicating this. Let's just do it the way that I was going to do it before. So let's make all these equal. And then let's kill the horizontal alignment thing here. And then let's actually do horizontal on these diagonals. There we go. That's what I wanted. Okay. So I wanted that to be horizontal, not horizontal. I wanted this to be diagonal so that we don't have to worry about, like, 3D printing artifacty thingies. And it's okay that's going off the edge a little bit because this is just for retaining the nut shapes, I guess. I realized, why did it select the whole diamondy thing for only, like, the right ones, not the left one? Oh, you know, it may have been because I didn't project stuff on there. That's okay. Alright, alright. So if we cut out that, and then go 2-sided, and then we also cut out -2, or maybe just 2. Yeah. It looks a little jank, but it'll work. And then we can slice this in half. And then we have 2 halves that we can, clamp around. And then we have this bit, which we just need to secure with maybe a few more features. And I don't think I'm gonna bother with, the thingy for, what's it called? I don't think I'm gonna bother with, what was I talking about? Oh yeah, getting those screws for the grub screws in. I think I'll just drill it out manually. It's not that important. Okay, so, yeah. Let's get that in. Let's, take the largest line, I guess, and also project that, just so that we don't stomp on it. And then here, want to add some retaining things so that we can, that actually happens to work out where it should be. So these will just be screws that we can mount the top part of the mold onto the bottom part, and then we should be able to clamp it all together. It is using a bit of an excessive amount of screws, but that's okay. I might not need to worry about countersinking this at all, possibly. And since this is gonna be like one-time use or something, I'm just gonna directly thread my screws in here too. Not too worried about that being a problem. Yeah, let's just go with 3.2 millimeters here. Why is that not fully defined? Oh, that makes sense. I think I'm just gonna eyeball that. I don't think that's a big problem. Let's go with like 36. Yeah, 35. Just kind of eyeballing the midpoint of that. Let's go 36. And we could also probably make this a little larger. Yeah. Okay. So yeah, we'll just have that go in here. We could make it go a bit longer. You know, I'm gonna countersink it anyway, just so it's a little nicer. So that we don't have things standing up. 3. Yeah, 3 is probably okay. Alright, cool. So, yeah. Let's change the visibility of this. Okay, I think that looks like a mold. So, save this. And let's add some colors on here, too. It's not actually gonna be metal, but let's make it metal anyway. Let's make that red for some reason. And then let's make the molds, I guess, this nice lighter aluminum. Okay, so we have a mold here. This has to be one of the most complicated molds I've ever made. And so we have this central roller hub thing, and, yeah, it's a thing. Oh, you know, this probably needs to be plugged up a little bit too here. I wonder how I'm gonna do that. I think I might just do a thing where, like, we have, I don't want to do that. What is your diameter? Okay, so that's just gonna be 3.5. I think I might actually just add, like, super duper thin, like, single wall bit here. So that, we just manually drill through that when we clean it up. Yeah, let's just make that, like, 2 walls. And then that should be easy to fix later. Yeah. And then we could also actually have, like, some similar breakaway features, I guess. Here, maybe. Yeah, let's do that. So let's project that hole. Let's project that hole. And then, I don't know where that one sketch is coming from that we keep highlighting. Oh, it's because Tilly did the wrong plane there. Okay, let's do that and that then. I think the only annoying part is trying to figure out which, where, no, actually I don't like this feature. We're just gonna print a plug for it. That's the simplest solution. Okay. So yeah, we're not gonna do that. Although, I didn't get rid of it yet. There we go. Nope. Okay, there. The plugs are gone. Okay, so we have the roller thing, and then we have this bottom part that it sits in, and there is... We could chamfer this so that it just sits in a little bit easier. Yeah. And then we have this one side that we put around it, and then we have this other side, so we can just split it apart. Hi, what's up? Yeah. So the Cradle of Pilth, what we're doing right now is, I'm redesigning the part for the pillpack spool holder so that, instead of, trying to, like, put it on a spool and tracking how much it spins around, we're just gonna pass all of the, pills through a roller and just, measure the roller's rotation, and that should be better to scale and, easier to prototype, I think. And right now I'm just, designing the, the roller mechanism for it, and the mold and all that stuff. So, let's shrink that down by 0.1. And then... yeah, we'll just have this go down negative 20-ish. And let's chamfer the bottom of this so that it goes in easier, and chamfers look cool, mostly because it looks cool. Let's extend this by 0.1, and then let's make a new sketch here. Okay, yeah, this plug is way easier than what I was thinking before. Let's rise this up by, like, maybe 10, actually. And then here, I'm gonna add a, why is there... oh, I see what's going on. Okay. So then here, this part's gonna be kind of funny. I was thinking that we kind of have like a, almost like a reverse funnel thing going on here. So 2, and which one's the longer one? Yeah, that's what I wanted. Okay, so let's go with like maybe 5. Or not 25, just 5. Okay. And then I guess here we could also extend this upwards. Let's go before we did that. Oops. Okay, so what's the height difference between this and this? 8. Okay, so let's go before the split. Let's make that like, I don't know, 5-ish. And let's make this go up by like 8. And then let's add a little bit of a funnel feature here. Was that 2 and 5? Something like that. I guess 8 and like... yeah. Cool. So now we have this... okay, cool. I think that's better. Alright, so... wow, this thing looks really over-engineered right now. Okay, so... and I think it's at the time that we name this. We'll call this one top plug. We'll call this one... side case 2. Side case 1. Actually, let's... no, we can just put in folders. Okay. Base. And... hub. And we'll make a new group for, mold. Alright, so we have our hub thing here. And then... so this is the hub, this is the part that actually is gonna hold the roller. And then... oh, hi! Sorry, I haven't gone back to you, yet, but I did accept your Discord friend request, so I'll be chatting with you soon. Let's see, we have the base here. Day's been going pretty good, pretty short, since I only woke up at like 5 p.m. I had like, well, no, I woke up more around like noon, and then I laid down and I had a really, really good nap. And I liked my nap, so I kept napping, because I liked the dream that I was having. So I just kept sleeping, and then, I woke up more like at 5 p.m. That's like 4 hours ago, actually. No, I woke up more around like 6 p.m. and I did a little bit of grocery shopping and I started the stream. I did not realize that my mouse is blue now. Wow. Has like little bits of bluish on it. I don't know if I'm gonna bother trying to get that off with like Magic Eraser, because it also might take off the silicone-ish texture, and I don't know, it doesn't bother me that much, although this yellow stuff here does weird me out. I know where that's from. Anyway. So yeah, we have this, the central hub here, and we have some screw holes, and then we can, we have this base, and then we have side 1 of this, and then we have side 2 of this, and then just that we don't get stuff inside of there, we have our top plug. And, we can just pour the, the Vitaflex down into there, and it'll settle in nicely. And then this is the part that I find to be pretty fun and satisfying to do, where, okay, let me hide most of that. Okay, so where is the normal thing that actually, it's probably better if I actually do like a real section view. So this is the part where I estimate the volume that we're actually going to use. So, let's see. Section analysis, I think, is what it is. And which plane is it? This one, yeah. Ooh, that looks cool. Okay. So, here, can I actually project? I can. Nice. Going to project this stuff here. And, just gonna kind of run that down into here. And I think that's a solid region. And then, yeah. So I'm not too worried about that lining up not exactly, because we're gonna do a subtract operation anyway. So we're gonna take... Oh gosh, I'm getting like really confused. Is that even a closed loop? I don't think that's a closed loop. Let's hide this stuff and fix it up. That looks like it should be a closed loop though. Because, like, that region is highlighted, so I assume that would mean it is a closed loop. Oh, you know, I think I'm also missing the revolve axis. Okay, let's see if we can revolve that. Yes, we can. There we go. New body. And then we're gonna take the hub, which is currently intersecting with that, and we're just gonna copy that, I guess. Does that actually work? Oh, that does work, okay. And then we're gonna do combine thing. We're gonna take the roller molded part, and then we're gonna take that hub that we just copied, which is going to be sacrificed to the subtraction gods. And then cool, we have the roller part actually kind of separated out here now. And then let's find just some kind of rubber, I guess. I need to get my do we have like a nice kind of soft rubbery-ish surface? Is it under other maybe? Screw it, let's just make it black plastic. Yeah, that looks close enough rubber to me. Okay, so let's hide the section analysis. However we do that. There. And hide this. Okay. So yeah, we have, I guess that's actually kind of accurate because there's like a little tiny film here, although let's also just maybe just subtract that out, like, nah, that's not necessary. Okay, so we have our roller now with the molded thingies, and I guess we have like 5 points of contact here that will deform when they are pressed against the medications when they roll through. So yeah, now what are we looking at? And I bet the print is actually really close to done. 8 minutes. So yeah, let's look at this again now. And let's rename this to molded part. So we start off with this hub that's being printed right now. Almost done. And then we plug it into the base, and then we put in one part of the side, we put in the other part of the side, we screw it in the bottom, the top in, and then we pour a bunch of the Vitaflex in there, and then we have our molded part, we wait 24 hours, and then we take off this part, we take off this part, and then we pull off the base, and we pull out the plug, and we have a roller. So yeah, that's a thingy. Okay, cool. That's actually ended up being right on time. I don't think I care about making these rounded, plus the sharp look is kind of cool. And then just wait for that print to finish. And I guess while that's finishing, we can actually take the mold parts and start arranging them on the slicer. Let's see if this works. I think this will work. Let's try exporting this as a roller hub mold as a single 3MF, and I think if we put this in non-fusion in bamboo, then we should be able to just split it out instead of having like save it in a bunch of different bodies. Okay. No, I don't want to update anything. I hate updates. They waste my 3 minutes of my life every update. Okay, where did this thing go? Where did I save it? Oh, that's not the right folder. What? Users... Pearl. Where's my 3D objects folder? There it is. Okay. Date modified, roller hub mold.3mf. Okay, yeah, I think that did what it was supposed to do. Yeah, it did exactly what it was supposed to do. So we have 3 separate parts. And let's just make sure that the orientations are sane. This one's saying the only overhangs are going to be these diagonal countersink parts. This part just flipped upside down, and I could probably use the brim. Actually, let's just have it per object. This one has a brim. And then I don't think anything else here really needs a brim. Well, just to be safe, that could use a brim also. Actually, no brim for that. That isn't a brim. And the overhangs are just diagonals, so that's safe. Yeah, I think this is fine to print. So let's just arrange this. Auto arrange. Wow. Okay, that's pretty compact. Slice plate. I'm gonna guess 2 hours to do this. Wow. Yeah, that's almost 2 hours. And we don't need this to be crazy because this is not structural at all. This is just a mold. And we're probably gonna use it like twice at most. And let's go find, okay, we have 3 minutes. I'm gonna use orange for the mold because I barely use this. This one. Okay, I'm just gonna load that in. And I'm gonna look up how to trigger ad breaks manually on Twitch because I may or may not need to take actually, let me go untangle this first, because it may or may not be tangled, and it's pretty easy to make sure it's not tangled. So, yeah, I'm just gonna unspool it till it's like all the loose stuff is not loose anymore. Okay, cool. Yeah, and then let's just respool this, I guess. Okay, that should be not tangled. Cool. Insert that into the AMS. Why is that slot kind of plugged up? That's not correct. Okay. Let's set this to orange, and just generic PLA. I need to change out my, barely see it, but I need to change out my, thingy, because that is wet. But yeah. It's 2 hours. Okay, let's look up how to manually trigger ads Twitch. /commercial, and I think I'm gonna do maybe 180 seconds because I need a poo. But I'll do that after the print's done. Which we're at the last 2 layers, so that's gonna be very, very soon. There, it's done. Okay. Sweet. Alright, yeah, we have this. And you can see all the little retaining features I was talking. You know, this would actually help if I had the light on. There we go. So yeah, all the Vitaflex are just gonna loop through there. And, where is my... Reamer is not the word. I don't know why I keep saying reamer. Where is my, deburring tool? There it is. And I think I may have left a, what's it called, Why is this not deburring as easily as it used to? Well, it's not that important, it's just... The brim's already mostly off. Anyway, yeah. So we have this. Okay, the printer is almost done resetting. And how much plastic is this, anyway? 64 grams, that's not bad. Just doing a sanity check again to make sure that anything does not need supports. I think I designed this in a way that doesn't need any supports. Yeah, that should be good. Okay, is this thing ready yet? Yeah, it's ready. Okay, cool. So let's get this printed. And what's the command? It's /commercial. Let's do 180. just gonna wait for that print to finish downloading. Just taking off my trackers right now, so everything's gonna look kind of weird right now. Oop. Okay, it is going. Alright, slash commercial. Let's go 180. Okay, bathroom time. Okay, is this thing working? I think this thing's working. Is the commercial break done yet? Well, I'm gonna assume that there might be like 60 seconds left still. So, let's see. I'm gonna show. Oh, he's so cute. Okay, I think I figured out how to show things live without my webcam. Look, it's JJ! It's a fluffy man! Look at my cat! Oh, he's so cute! Wee! JJ! Oh. Kitty cat, kitty cat. Yeah, normally he likes to hang out down here, which is like right where my workbench and like computer are. But now he's being polite, and he's actually sitting on the futon / napping on the futon. So he's not in the way of a high traffic area where he keeps getting stepped on and then whines. And I'm like, dude, you're in a high traffic area. I try not to step on you, but if you're there, it's gonna happen. Woo, he's so cute. Whee! Okay. Anyway, I did give him lots of pets right before I showed that clip, but I only have so many hands. He's getting pets right now. Okay. Okay, by this time the commercial break should definitely be done, and it looks like the first layer of the print is going well. So, yeah. That means that next we have, I guess, we have the rest of the thing to design. And, yeah. So, this next part, I think we need to design the spline next. Is spline the right word? The shaft? Whatever. Okay, so let's get this dude. Let's offset that by 0.1. And then let's have it extend past, or start here. No, actually, we don't even want it to extend yet. Just have it go all the way down here first. Let's take the molded part here. Oh, did that merge with the molded part? Where'd it go? I don't think I actually, modeled it. Okay, there. So let's hide the molded part. And then let's get rid of those holes and add the, heat set insert things, I guess. Hide the hub. And, I just realized this might make things a little difficult. Ouch. That hurt. I'm gonna get some hardware out and see what my options are. I may have made it a little bit too close to the edges, so then that makes putting a solid shaft through the thing rather difficult. But I do have some pretty thin heat set inserts that could work for this. So, how thick are you? I think you're gonna be 4. Yeah, you are 4. And if that's 10, yeah, that's still only 2. Not ideal. But we can work around it. Yeah, let's not use these ones. Let's just use the full length duties. If it's really that bad, we can remake this. I don't think it's be that bad, though. Okay, so this whole thing is 8 millimeters. And this is what I was originally planning to use for this anyway. And let's see, the width of this is 6 millimeters. Wait, is this even... I don't even think that's M4, I think it's actually M3. Oh wow, this doesn't even recognize that it's a circle, it thinks it's just a curve of some sort. That's not a circle. Okay, but this is actually sized for M3, so let's not use the M4 ones. And let me close the container that scratched my leg a minute ago. Ah! That was weird. Okay, I just dropped my M3 tackle box again, but at least it's closed, but I can't reach it with all this crap on, so I'm gonna take that off now. That could have ended a lot worse if this was not locked closed. Oh. Okay, we're back. Could have sworn I had more. I do have more, actually. They're off to the side. Yeah, I have one here. Okay, yeah. Here's an M3 heat set insert. Okay, so the length of that is still 8 millimeters, and the width of this thing is 5 millimeters. So, yeah, let's do the same thing here. Actually, let's just delete all of this. Let's see if it actually recognizes a circle. No, it doesn't recognize a circle out of any of that. It's okay, we'll just use the center of that then. Okay, so let's make that 4.8-ish. And let's go -8 on that. And that should let us put 2 heat set inserts in here. And this is really not going to be a high stress part, so I'm not too worried about, like, not being able to put, a whole solid shaft through that. But yeah, so we have the hub and we have the molded part here, and that will all just kind of go through like that. And with the molded part, we're just gonna have to kind of poke around. It's gonna be a bit messy, but we're gonna just have to poke around for where that, where these holes are, and then just like drill through it, and then we can put the grub screws in there. So it's a little messy, but it's not that bad. Okay. So if we have this, I think it makes sense after putting some features in here to, yeah, I think it makes sense to, make a new part after this. Let's take this, and let's do maybe 8 millimeters, yeah. So let's have you extended by 4. We can do 10 actually. We don't need to be stingy on that. And then let's take that same sketch and let's hide that part for now. There we go. And have it start from here and oh wait, start from, oops, actually screw it, no, actually let's take this, and then let's have it start from object. Maybe we could have it start from there, actually. It's a little jank, but it could work. And yeah, that is part of the same body. And then we have a roller thingy here. I don't think that we're gonna need bearings here, to be honest. This just doesn't seem like something that needs bearings. I could also print this out in ABS so that we can sand it easier. I think I'll do that. And you know, just so we don't need supports, we could also chamfer this stuff here. And I'm just gonna be symmetrical because that's gonna look nicer. Let's make it equal distance. 1.5, 4, 3, 4, 5, 4, 3, yeah. Okay, cool. So yeah, we shouldn't need any supports there at all. Yeah. And it's okay that that's tucked in a little bit here. That's not gonna be a problem. Yeah. Okay, so diameter of that is 8, and the width of this whole thing is 75. So let's add maybe 2 millimeters-ish of wiggle room on that. And let's also make that like 8.2. And then what is the radius or diameter of that? 36 millimeters. So let's make that 36 so you can visualize how the thing will rotate around, construction. And, yeah. So right now, working on the little arm thingies that it'll, like, move around on. And let's make that horizontal. And let's add this here. And let's get a distance here. So let's find what kind of the thickest worst case scenario of like the pill thickness will be. I mean 10 if it's like this way around for some reason. But in most cases it'll probably be like around maybe 3-ish. 6-ish, something like that. So, and I mean, the grooves are in there, and we're using, VitaFlex, so it can be compliant anyway. Let's make the arm like 45 millimeters, I guess. So I'm just trying to visualize how much it can actually bend. And you know, that's actually kind of a lot. We could make it the same as the radius. So then here would be at about, that looks like 30-ish degrees. Is that correct? Yeah, that's almost exactly 30. We have like basically 0 clearance. And then the maximum you have here will be 18. So I think 36 actually good length for that. And, yeah, let's just make that like 60, I guess. I don't know, just seems like a nice number to have that at. So yeah, that means that we can have it kind of flex like this. No, actually it won't be flex like that. It'll be kind of more like let's add another slot here. Let's make it like maybe just 10. So then whatever that length is here to here, that's 10. So that'll be like the worst case scenario. And then we can have a spring go from here to here. This also doesn't have to be that thick. I know why it is that thick. Yeah. Because then if this is like a 4-ish millimeter hinge shaft, I was using some like M4, M5 partial thread or like shoulder bolts. That should be beefy enough. I mean, we could kick this up to like maybe 12 millimeters, I guess. If we make this longer though, then it'll be more likely to be on the center the whole time. And then what's the distance between this and this? Between best, or I guess the tightest case, 36, and the longest case would be 66. So do I have any springs that kind of fit that profile? Or anything close enough to that profile? So was it 46 and 66? Yeah, that should work. I think this one's a little shorter. If it's not, no, that should work too. Have these ones. Ooh, that one's actually tighter, even though it looks smaller. Have these ones. So yeah, we have so many springs here that I don't think that we're gonna be limited on that stuff. And we can also change the mount point slightly. Yeah. So let's just hide that for now, because that's just kind of like visualizing stuff. And then let's make you, I don't know, radius of 10 millimeters, I guess. And let's just make you a vertical so that it's easier to mess around with, I guess. So, I don't know, let's make that 6 millimeters. And then just think about how this would be constrained. Just gonna put like a little imaginary line here also, just so I can like visualize how far we can kind of cut in before we lose that like 10 millimeter minimum thickness. And let's also just kill that line being that way, although there we go. So 10 millimeters, we can actually get away with quite a lot. 10 to 0. Because I'm trying to think of like, if we have 2 of these arms here, and then we want to like have them connect at the middle, so that it like stays kind of parallel, what we can get away with before it does not want to let the things pass through that should pass through. So I think if we have this kind of geometry here, and then if we make this bigger than 36, so let's make that 40. And then yeah, so let's have this go tangent to that, and then we can lock that in, and then we can have this silly geometry here. And then if this is not tangent, okay, that line is still going to move around there, so let's have that not be aligned with that. Can we kill that alignment? Maybe not. Maybe we just have to, like, kind of fudge it a bit. Yeah, we'll just make that, like, 60. Oop. BattleBots, me and some teammates were talking about, like, the equivalent of, like, vibe coding, but for, like, doing CAD, but, like, not so much in terms of, like, get AI to do it for you, but just more so in terms of, like, just kind of not defining everything and just kind of letting everything be loosey-goosey, and I feel like that what I'm doing right now is kind of that right now. Okay, yeah, that should be fine, I think. Yeah, and let's make that, okay, now it's fully defined again. So let's make that go, 77 divided by 2. Negative 77 divided by 2. Have that be joined. And then let's do a mirror feature of that whole body on this plane. Combine that, make that sketch. And then we have, let's call it linkage thing. And then we can figure out where the, okay, and for now, we'll just have this go in here. And we're just gonna fix the roller hub for now, but we want this to be free eventually so that the base is what actually moves around. And we'll call this roller assembly thing. And I want to hide that sketch, because I don't like seeing sketches in my assemblies. Okay, so we take the linkage thing. And that happens to line up pretty nicely already. Let's constrain you to you. And then it'll be offset by like 1 millimeter. Okay. And let's get latest so we can hide that sketch. Alright, so we have this. Looks like nothing is colliding there, that is good. The thing can freely spin around, and I don't think this will see forces that'll make it twist out of axis or whatever it is, or whenever you have like 2 axes that like get kind of like crisscrossed or something. I forgot what that's called. But when the axes do not become parallel anymore. Okay, so we have that. And then now I guess we just need the base of this. So we'll just look at what we did here. It's pretty simple. I'll just screenshot that so that I can look at it on my top screen. Okay. So for now, let's just have a simple, you know, I think a curved slot actually might be good for this. Something's just telling me that a curved slot would actually be really good for this. So let's do that. And then we can just define the deflection by whatever this is. Let's go with 2 millimeter deflection, radius 6 millimeters, and then the width of this 60 millimeters, and then we have a hole here that's gonna be 4 millimeters. Yeah. And then this can be 75. reason I'm thinking we have just a single, but why we have it be curved is so that, like, we have less contact along the passive surface and more on the frictiony part, if that makes sense. Probably doesn't. But let's go put this thing in here now. Oh, that lines up just fine. Wow, that lines up almost exactly. Okay, so let's actually fix this. I guess it's pinning that. It's really pinning and fixing. Because I think this one's fixed because it has an anchor. Grounding is what they call it in this. Okay, so I don't think that can be moved, and this can definitely be moved. That is intended. Let's constrain you to you. And let's constrain the edge of you to the edge of... ah, fuck. Okay. Let's constrain that face to this face. And then... yeah. So we have this. I think the next part is to just extrude out chunks of that so that it's flush, and then we can add spring thingies. Yeah. Okay. And I can still actually refer to that part. So let's take a slot. And I'm just looking at, like, this screenshot that I took. It's on my top screen. But let's make that, this is the radius, right? Yeah, radius 10. And then this is gonna be 36. So let's make all of that construction. And then the length of that is 40, and I think that we have kind of this thing defined. Yeah, it's defined. So when this thing is closed here, and let's actually shrink that down a little bit in case we have a bit of compliance. Let's say that compliance is a maximum of 2 millimeters. So let's make those tangent. And then if we take this and make that parallel. I think it's already parallel, maybe not. And just give it, like, maybe just 1 millimeter of space. Plus that. And then whatever the thickness of this was, that was 6 millimeters. And let's also take that. You know, I think I actually want to make that divided by 2. And then we'll just keep mirroring this entire thing at the end. And then we can add some little fillets, just make it a bit nicer. Okay, so let's update this. Cool. So if this thing squishes down like 2 millimeters-ish in, then you get it closed like that. But it's probably not ever going to be that squished, so this is going to be the most closed it'll look like. You know, I think that needs to be extended actually. Let's make it 7. Let's make it flush. Okay. And you know, just so that this can actually be printed flat, it might make sense just to, tangent that. Yeah, let's do that. know, since this actually swishes so much, let's actually make that like super small. Because we already have like some squish factor factored in. So let's get latest. And that's like if we have super duper squish factor going on, which I don't think we'll ever get. So when we're here-ish, I know that's a little too close for comfort, I think, here still. Yeah, we'll just add a bit more space here, just in case. Because that, getting it closed like that is really just aesthetics, so for screwing something over just for aesthetics, that's kind of pointless. Let's make it 1. Okay. So, let's get latest. I wonder if there's a way in Fusion to automatically always get latest. And I think that here, adding a bit of rounding to this should not hurt. And then I think here we can actually add some guides so that it continues to pour out. And I broke my rule of don't put fillets in early, put them at the end. Okay, let's have a guide, maybe like 4 or 5 millimeters. Yeah, like that. And then, is there just like a automatically get, oh, I just pressed that. Okay, that's good to know. Okay, so the medication will just slip through this. Yeah, that seems reasonable to me. Okay, so I think the next part is figure out how the springs attach. I think with that we need to shorten that a bit also. Well, no, springs are easy to figure stuff around. It's the encoder that's going to be kind of the issue. So, let's see. 3 millimeters. Let's shorten those stick out things by 3 millimeters. It's going to be -7. 7. Update that. Get latest. Now that is flush. And then get back to here. There's like a tiny, tiny little magnet that I just lost. I need to find that tiny magnet is important. I mean, we have a bunch of them, but it's a special axial magnet. I think is axial, but it's whatever the one where it's like a circle, but like a half circle is one pole and the other half circle is the other pole, instead of it being like one flat side is a pole and the other flat side's a pole. I don't know if that's axial or if that's radial or something. It's one of those, I think. Well, it's okay. We have so many of these. I can just find that one later. I don't want to bore y'all by trying to find a tiny little magnet. So we have another magnet here. Yeah, here's the magnet. It's very, very small. And so that needs to be embedded at the end of the shaft, which I think we're just going to epoxy that in. It's not going to be that crazy. So that's going to be 4 by 2. So we're just going to have like a little tiny pocket in here for the magnet to live in. let's make that 4.2-ish. And then we can sync that in by like maybe 0.25 or negative 2.5. And then that's gonna be where the magnet lives. And we might as well just model the magnet in here just because it's easy to do. Oop. That should be 4. And we'll just have it offset by like, 0.1 and distance 2. And let's add little tiny fillets to it so it looks a little bit magnet-ish. Yeah. Okay. Appearance, chrome. What? Is there no chrome in here? Okay, just some kind of metal. There is chrome. Why didn't it search? Okay, well, anyway. Cool, we have an embedded magnet in there now. Hide that sketch. Save that in hide. Update. Okay, now we need to figure out how we're going to put the encoder on that. But, it's pretty easy, because we just have this whole pattern, and it just needs to sit above. The magnet just needs to, like, live above this thing, and then it'll just, like, spin around it, and this tiny chip is the actual sensor itself, and that will know when it's spinning around. So the clearance on here that we need, let's see. Everything is pretty far out of that, so we can just put, like, little tiny offsets on there, and then... yeah, and then the height of that chip is just zeroed out. And we can check the data sheets just to make sure. But, it does seem wise, actually, to just model this thing anyway. So let's do that. Alright, so that is 22.8 by 23.3, so it's not a perfect square. So, 23.3, 22.8, and then getting the distances of that, that's 16.15-ish. 16.15, so at least the mounting is a perfect square, though. So I'm wondering if it was meant to be a perfect square, and this is just, like, slight manufacturing imperfections. Make that equal 16.15-ish. And the hole size is 3.4. So that's suitable for M3 screws. This part's not going to see high stress loads, so I'm okay with just directly threading into it. And then this part is going to be the sensor. The sensor is about, I'm just going to do the whole thing including the legs. 7 by 5 and about 1.8 tall. And then the thickness of this is, the PCB is 1.5. Negative 1.5. Let's add some fillets on this. Yeah, 3-ish is probably fine. No, maybe 4, actually. And, yeah, we have enough keepaway zones to add some offsets without it being mad, so I'm not gonna worry about putting little tiny components on there. And let's make this white, I guess. Oh, are those actually two separate bodies? They are, that's funny. Okay, I'll take it. Oh, I see why. It's because this part's not filled in. Not spicy. Okay. Yeah, sure. Let's just do that. Okay, so I'm gonna actually just kind of fill in that gap a little bit. And then it looks like it's just two separate components. We can call this one the encoder. Okay, and I'm just gonna screenshot this for reference so that we can model it, or model where it should sit on the linkage thing. Okay. And let's check the data sheets also for that. Okay, what is this? Let me go check my Amazon purchases. What is this encoder? This encoder is AS5600. Oop, that's the wrong window. Here it is. Okay, so this looks a little different. I mean, the board is different, but it's the same sensor, so that's okay. And then we should have data sheets somewhere. Technical details. That's interesting. They're putting it under the board instead of over the board. Okay. That's a cool dollar design. Don't care about pinouts. Just trying to find how far the magnet should hover above or below the sensor. Output timing magnetic. I mean, this is kind of easy. I'll just see magnet distance. Ah, there. So it wants 0.5 to 3 millimeters. Let's go with 1 millimeter for now. Which means that, that's 1.8, so 2.8 millimeter offset, and I don't think I want to bake that in to this. I think I just want to put like shims and washers. Okay, so whatever this was here, let's make that equal. Oh, only two of them can equal. And that is a me, what, 16? Like 15? Ooh, that's just past the edge. Okay, so that needs to be extended out a little bit, I guess. Okay, let's see, those dimensions, let's make that 24 actually, so that the stick out is like just a little bit past the PCB size. Equal. And that's gonna be M3. Okay, so we have that. And then we can also cut out the holes. Okay. And then I do want to add some fillets there later. But yeah, now we have this. And let's design some washers real quick. So it'll be M3 washers, and I'm just trying to get the max, or the minimum, or I guess the maximum size that we can make them. 1.5-ish. So 3.4. And the thickness of this is going to be 1.5. So that's going to be like 2.5 walls. And let's make that like 3 millimeters for now. So we'll just call this one spacer. And we'll just give it a funky color. Let's make it brown. Okay. So let's insert 4 of these in here. You know, it might be easier just to do that and then copy it however many times. Although I actually think constrained components or rigid group might be... Nope. Let's not worry about that. Okay. So we have that, and then we have going to there, and then let's just copy pasta that a bunch of times. Okay. Where'd that go? Let's just line up the faces first. Okay, so those are lined up. And then we can add this encoder. And I want to have it tucked in instead of hovering above or below or whatever, like that one thingy did, just so that we can hide the electrical stuff so that it'll be better protected, I guess. But let's constrain that to there. And how do we do the flippy flip thing? There. And then constrain that to there. And then we move this over. And then we can constrain the face of the PCB to this. And then I believe that should make it so that, depending on how we glue it in, that's gonna be like minimum distance of somewhere between 0.5 and 3 millimeters. Yeah. Cool. Okay. How much time do you have on the print? I think we probably have 1 hour. Yeah, just under 1 hour. Making it on time. And then I can actually do the demonstration. Okay, so that's gonna collide a bit here. So I need to cut that out a little. And I'm just gonna eyeball it. We'll just adjust the numbers as we need to. Okay, so... Oh, that's not actually too bad. So we can add 3 millimeters back to that. 9 millimeters. Okay, cool. Yeah. So we can get the, so this thing spins around, and, I just realized we don't actually have a way to make sure that, we can actually insert this in and out, because that's 2 rigid pieces trying to go into each other, and that doesn't work. Okay, so how do we resolve that? I think the answer is kind of easy. We just cut out that bit here, and then we just screw it in. Yes. So yeah, let's try that. Doop. Doop. Delete those, and then I think we have this entire thing here that then we can just offset that by like 0.1 or so, 1.5, something like that. And then we can cut that by 3. And then take this. Do that. And then hide the body. And then 0.1. And then that'll create 2 separate bodies here. One being insertable into the other. And then let's go with that. And just kind of eyeball that a bit. And then 21.5, I guess. And then that can just be a single plastite, and then we can just epoxy that or something, or plastic weld that. Won't be too big of an issue. And then, yeah, we can go like -20 on that. Okay, cool. So that should let us actually separate them then. Not bad. Okay. I don't think I want to do it on the other side. I think I just want to keep the part count low. Okay. So yeah, that means that we'll just have a screw here, keeping that together, along with some glue or some plastic welding on that, if we want to make it permanent anyway. And then this thing should be able to roll pretty free. We may need to sand or ream out parts here, but that's okay. Worst case, we can just use some bearings. And let me just check, because that's 8mm. What's a 608 bearings dimension? What the? 608 bearing. Oh wow, 608 bearing actually does let us put that in there. But I also don't think that we can fit it in with that stuff going on, so let's not worry about it unless it's an issue. Then, if it's an issue, we can design it in. I don't think it's gonna be an issue. Because this thing doesn't even need to accurately detect rotations, it just needs to detect that there's some rotation, which means that I'm pulling some medicine out. And let's colorize the stuff, just so that we can see different components a bit easier. I'm just gonna use some random colors. Let's make you blue. And let's make you green. Okay. So yeah. I think the springs might be the last part that we need to get kind of the minimum thing working. I'm gonna go put those fillets in there though. I think that needs yeah, let's do fillets. Why not? If there's any problem I foresee, it's gonna be possibly the medications kind of rolling off and out, but I think there's a possible solution for that, where we just, where's the roller assembly? Here. Where we just add something here to keep the medication going through that. So let's do that. Okay. So let's project this. I don't like that. Let's do an offset properly. It doesn't need to be that big. It's 3mm, I guess. Bless me. Just gonna eyeball this again. It doesn't need to be super accurate. The vibe of this is gonna be kind of like cash register-ish with like the receipt printer. I don't know. I don't know what I'm doing with these angles, but maybe if it's parallel to this, it might look okay, I guess. Yeah, that doesn't look bad. Okay, so... No, that's not even connected. Cone send it to that. And let's just have this be like 0.1. Yeah. So we'll have you Noom all the way there. And then we will Noom all those over. And we also wanted to mirror, I guess we never mirrored that one. Can we not mirror multiple objects? I guess we can. Okay. So there's still two separate bodies. And let's just make sure that, this clears. Ooh, it barely does. I guessed correctly. So this should keep it on track, I think. And we can add some filleting feature, I guess. So that, it doesn't have to taper out like that. And also just to make it easier to print. Maybe 0.5, yeah. Let's maybe also add... Oh, okay. So that's how I add additional fillets onto an existing fillet. That's good to know. Just hold control down. Okay. This part's a little tricky because this isn't like a true plane though. So I guess I have to make a plane from maybe going through like two edges. Yeah, that sounds good. Let's have it just go through there. Close enough. And then here I want to I just want to be able to add some like screw holes so that we can clamp that thingy in there. So let's go add these lines here, just so that I know where I'm at. And then I think that's gonna be 3.5, yeah. And then we'll just kind of vibe that, I guess. Yeah, 3.2. I'll just drill out the holes to be a little bigger. 8. No, that's a little too much. Let's go 6 maybe. This one, maybe 6 also. Yeah. And then we'll just have that drill out. Oop. Let's make everything here. Whoa. Let's make all of that construction except those circles. Actually might need to be a little further out just so that they don't bump into each other with the screw heads. I'm learning a lot of keyboard shortcuts this stream. Okay, so direction, 2 sides. Yeah, that should be fine. Visual style, shaded with hidden edges. Let's add some countersinks here. Yeah. This is gonna be a bit wacky to print, but not that bad. And And then, yeah, the medicine should just flow through there. 5 millimeters? I don't know. That might not be enough. Let's maybe make that offset bigger. Let's make it 8. And let's make sure it still does mechanical things properly. Yeah? Oh, that needs to be extended here. Probably another 3 millimeters again. So wherever we cut that out, let's make that 12. I was not happy about that. Oh. Okay, let's make that maybe 14. Okay, let's update this assembly, and we have clearance again. That is good. So this should keep the pill pack stuff routed through that, and I really don't think that we're gonna get past like 8 millimeters. And if we do, we can just reprint this part to be thicker, or have like a bigger offset, I guess. So that's not too big of a deal. So now I think we're at the part where we can add the springs. I think that with the springs, we can actually kind of just hide the encoder part, and then we can just put like mounting thing here and mounting thing there. We also could just extend it out here so that it just doesn't get in the way of anything moving around. We can also put it down here, which means that'll only be stronger and it doesn't have as much of a range of motion. We have like so many springs though that we can definitely adjust things. And I think that we can also definitely add a bunch of different holes to mount the springs on so that we can experiment with different tensions without having to commit to a specific one on a print. So I think that is probably the way to go, actually. We could also actually share some mount points also. I think sharing the mount points actually might be the way to go with the encoder screws here. Wow, my tracking's going nuts again. Whoa. Okay. Okay, let's just look at my spring availability. And my trackers are coming loose. Oh, I think I'm wearing it wrong. Okay. There we go. That's more secure. Yeah, we've got a lot of springs at our disposal. So I'm not really concerned that we're not gonna find something that fits. I think something along here might be a good size to go with. Kind of thinking that we put the spring here to here-ish, and that'll keep it out of the way, and we can do minimal modification to both parts. So let's go all the way back to here. Yeah. go add thing to put a, this part will actually see some stress, so I'm going to be using plasticites for it, I think. Plasticites are just, these screws are made to go directly into plastic without having to put, like, heat set inserts. So your diameter is 3.5, so we'll make you 3. And then let's see if 20, maybe no. Let's make it a little past that. Let's go with 25. Might be okay. And that is 6 millimeters thick. That is plenty of thickness to go around. Okay, and actually before that, let's also add a little chamfer so that it just threads in a little bit easier. 1 and 3? Yeah. Do like 0.5 and 3. Yeah. Okay. So if we have that... Yeah, that... as long as it's, like, kind of along this line where, like, this almost approximates it, then we can definitely keep it out of, danger is not the right word. We can keep it out of the way of the encoder easily, but I think that we need to pull that down, maybe not quite 25. Let's go with 20. Although I don't like that it does collide with that little funny bit there. Maybe we could do like 22? Yeah. Okay, so at 22, I just don't see that colliding with this at all. I don't quite know how to actually model a spring. I have ideas, though. Okay, so I think this is probably gonna be the candidate spring size we want. So we'll just kind of do something kind of janky with that. Okay, so that's gonna be... Let's see, how do I want to do this? I think... I want to do it so that that's like 15 millimeters by 5 millimeters. Let's round that up to 6 millimeters to be safe. And then... you know what? Actually, let's not have it at the center. Let's actually have it offset from the center. So that is 5. And then... what? Okay, there. Okay, so this loop size is like 5.5. And then we'll just say that that's like 0.1. I guess maybe like 0.2, I guess. And then we can just sink that in just a little bit. 2.5. This is not gonna be perfect, but it's okay because the springs are not perfect, I guess. Oh. That should have been a join. Okay, cool. Spring jank. I'm not gonna worry about making this a spiral because that just might be too much geometry. Okay, let's make this something kind of satiny. Satin. Okay, so we have one half of a spring, and I think that what I'm gonna do is I'm gonna, like, just kind of, have two springs, constrained to be almost like a pistony thing. And then we can see kind of the springiness motion, I guess. It's not gonna be... I know, it's kind of jank, but it could work. So yeah, we're gonna take that spring, and, gonna copy and paste it, rotate it, and then constrain components, so that those are always doing that thing, and then constrain that to be against there. Constrain this to be in there. And then this is like really jank. I wonder if we can just like fix this temporarily. Whoa. That was not good. Maybe pin? Yeah. And then we can, do some silly shit here. Constrain that component. That face to here. And then we can kind of imagine where the holes should go. Which... I guess that's like probably 8mm, and we just make that a line. Base. Okay. So... 10's actually kind of high. Probably more like a 6, I guess. And then we can just add a bunch of holes here casually. We'll just have this one start at like 5, and then rectangular pattern that over like maybe 5 different options. Each separated by 5mm. Sounds good. And then we'll just directly slice through all of that. Okay. So let's update this, and then we can unpin that, and then we can try out different mounts here. I have a feeling that's gonna be that 4th hole, but we can try it when we actually print it. But yeah, that's extreme. I wonder if we can get like a live measurement of like this to here. not actually filling that one. Could actually have it, well, I mean, this is what trying out all the different little holes is gonna be good for, is that we can test out all these different ranges, because I want to assume that, like, maybe when this is, like, all the way out here, that means that, like, that's probably the most we want to stretch that for it permanently deforms. And then this is going to be kind of its natural state, and it can't really go any closer than that, so it can't be that one then. Let's try constraining that to this one. So then when this one is almost fully squeezing in, then we have the roller going against the surface. And then when this is basically almost at, like, peak height, then it's stretched at, like, double whatever that is. So I think this third hole is probably gonna be our sweet spot. And we're also not interfering with that encoder. So, yeah, I have a feeling that's gonna be the sweet spot, but we have so many springs to try out, and we have all these different holes to try out too, that we can definitely experiment, and it won't be an issue. Yeah. And then, I wonder if I can just mirror that easily? Do we have, like, a mirror thing? Nah, I don't want to mirror it. That seems like work. We'll just, replicate it on this side. Okay, cool. So those are now coaxial. And then we can also make these faces always align. And then this one we don't have to worry so as much about if that actually aligns with that. And then that circle to the third hole. Cool. Yeah. That looks like a thing that'll work. I think it'll work. Alright, on the print we are 21 minutes away. And I do want to wrap this up soonish. Let's see. So let's go back to the to-do list of things to make on that. Okay, we have the roller center, the roller hub. We have the mold, we have the base, we have the side hinge. Yeah, I think we actually have all the parts that we need. Oh yeah, this needs a way to attach the things. And so, I don't think that we need attachment points on anything except the base. And for the base, we probably want to be flexible, so, yeah. I think that we want to expand out past this radius here. So, yeah. this go tangent to that line. So then that's gonna be 22. And then... yeah, we'll just play with geometry until it looks nice. Right now, we are actually making probably the opposite of a death machine. This is, the Cradle of Pilth, and it is meant to, help me track my medicine taking. So, yeah. It's, it'll be connected to my AI assistant so that she knows when I haven't taken my meds, especially my ADHD med, and she can yell at me for not being productive, because, yeah, I normally build death machines, but, this does use some techniques from the death machine stuff that I'm making, because we have this, roller here, and, we have this central hub with a bunch of, retaining features, and we're going to be molding basically a giant tire around it. So this is the mold, and this is the plug on the top to keep the stuff out of the middle shaft. And then we're gonna pour some urethane in there, and then we have a molded part, and then we take off the parts of the mold, and then we have this roller thing, which is exactly like how I build my combat robot wheels, which this is just some leftover tire material from like another mold. I had like a very small wheel line. Here it is. So yeah, it's a really tiny wheel. But yeah, pure 3D printed materials do not have good traction, so we're gonna be molding stuff for that. But this does follow quite a few things of robot combat design, though. So yeah. Okay, so... oh, wait, I did not need that extended all the way there. Let's just... yeah. So I guess let's have this be parallel to that. Make that tangent, and then make that coincident there. Okay. Now, let's pull that all the way here. And then, I guess here, let's just pull this. That probably needed to be extended also. Construction, no, not construction. Collinear. There we go. Let's take that. And let's go from here to here. And then hide that sketch. Then if we reflect everything, fillets. There, then we can add that fillet there. No, actually I don't want that fillet there. 2, 3, 4, 5, 6. Let's make that 1. And then let's ultra super round this one out here. Yeah, 5. That should be good. And then let's see how this lines up now. Now that we have this base thing here. Oh yeah, that looks self-contained, I guess. And we'll just make sure that, yeah, okay, so that's lining up well. Okay, so the medications will pass through this, and yeah, I might as well just model, like, some little medication packs. And then we can just see how that kind of passes through, I guess. So, let's see. Each pack is about 78 by 69, nice. And they're just kind of funny little jank shapes, so yeah. Let's make that, okay, 78 by 69, right? Yeah. And then this is gonna be like, what, 0.5 millimeters? And then I guess VTubers can kind of come in like any package they want to be. I mean, like, there's a peanut. But yeah, I'm they them though. So yeah, somewhere in between. Yeah. Okay, good night, Alex. Thanks for tuning in. Yeah, you should probably get sleep before listening to lectures and stuff. Let's make some random little pills here. Might as well base them off my real ones. We have like 5 circles and 3 capsules. Yeah. And the biggest and smallest sizes are, I think, 10 millimeters. Versus, like, oh, one of them's not a capsule, or one of them's not a circle, one's an octagon. 10 and 8 millimeters, I guess. Okay, I'm gonna get rid of the octagon, or get rid of that one and put in the octagon. Oh wow, that should not be 8. That's a massive pill. 10, 8, 8. Let's put some capsules in there too. Okay, I should probably just take this to my desk, since there's a lot of random sizes to get on that. Okay, so then that's 6, and that is 7.5, and that is 7.5. So let's go with 6, and let's go with, I think my print's done already. Oh. We're out. How are we out? We shouldn't be out. I think the filament just snapped because it's kind of wet. That's okay. Hopefully it didn't fail, though. I mean, if it did, it's only 2 of the pieces that got messed up, I guess. Okay. Hopefully that works. If that works. Yeah, I call everyone dude, don't worry about it. Okay, let's get these lengths in. How many minutes do we have on that print anyway? We have 10 minutes-ish left, so that's good. Kind of just bored catting right now, waiting for that to finish. And then I can get to molding this shit. Okay, so the lengths of these pills are 18 millimeters, 18 millimeters, and this looks like 20. Yeah, 18, 18, and actually 22. So let's go with 18. Go with, oops. Let's go with, 18. And let's go with, 22. Okay, cool. Yeah, that looks like a viable arrangement of pills, and then thicknesses of these pills. I mean, honestly, most of these except the octagon are like, oh, 5.5 millimeters. Okay. And this is just like super rough. We don't really care too much about being accurate here. Octagon's like 3, and then the capsules. Yeah, this is Fusion. I keep saying Fusion 360, but I think they got rid of the naming, the branding of that being Fusion 360, so that's just Fusion. 6, and let's make this one 7.5. And then let's round it out those ones. So that's gonna be 3. So it's gonna be 3.75, I think? Yeah. And then all of these ones just gonna be a little bit rounded out. 1. Can we hide that? Nah, we can't. Okay. Well, yeah. So this makes it look like it's vacuum packed, but it's not. And then we can daisy chain some of these. Okay, I usually use SolidWorks because I got a free license, but how do you like Fusion compared? If I have experience with both? I do have experience with both. So, the one I was using right before this was actually SolidWorks, but, before I started doing commercial-ish stuff under my consulting company, I was using SolidWorks, but under, like, an education license. But the thing is that the SolidWorks Maker license really sucks, and the education licenses got really restricted, and you can't use the education licenses to make a profit off of stuff. And I do use CAD stuff in my businesses, so I can't use the SolidWorks education license anymore. And the SolidWorks commercial license is like several thousands, I think, while Fusion's is only like 400 a year. And I generally think I like SolidWorks a bit better, and I don't really like how I always said Adobe because what's it called? Autodesk is kind of basically the Adobe of like CAD stuff anyway. But yeah, I don't really like how Autodesk keeps putting more and more stuff between like cloud tokens and under subscription, and like taking away stuff from the free version of it. I just feel like that's kind of predatory with like baiting people into getting the free version of Fusion and then take away features and make them pay for stuff. But regardless, since I do make money off of my CAD projects, I can't be using the free or the education versions anyway. But yeah, I've used SolidWorks. I'm using Fusion right now. I've used both. I think I've used Fusion for maybe 8 years, and SolidWorks since a high school internship. It's at least 15 years. I got started on Autodesk Inventor, actually. And I've used Onshape a little bit, but like, once you know 2 of them, you can pick up most of the rest of them, except FreeCAD, because the UI on FreeCAD is just not refined at all, and any criticism of the FreeCAD UI gets you some stern words from the people that make it, some of them, at least in the past. I heard that they're working on making it better, but it did kind of turn me off from it a bit. Let's make this just plastic, since the packaging is plastic, and we'll call this pill packet. And we'll just, because it's a strip of that, we'll just have like several of these. Spacing should be 78. And we'll have 5 of these, I guess. Can we merge them? I want to merge them. Yeah. Oh, that is not a merger. Join. There we go. Okay, cool. I think before that, let's actually just add a little bit of a thing so that we can kind of imagine a bit of a perforation. 0.6. I mean, I don't know if they can prove that you've made a profit off of it, but I guess when you, like, just own a business, you just don't want to get in trouble and, like, get sued by other businesses, because, I mean, frankly, and this isn't, like, an endorsement of piracy, I'm just covering my ass, but, like, if you're just pirating stuff for, like, personal use, most companies don't really care, but once you start making money off of it, then they send the lawyers after you, and, yeah, you just kind of want to be squeaky clean when running a business, otherwise that's how you get in trouble with, like, taxes and getting sued and losing your business and all your assets involved with the business, so, yeah, just rather play it safe. Those are merged together. Yeah, it's a single body. So let's take that assembly. And I think we have like... I thought that I finished that already. Yeah, and it looks like the print was not affected by it, which is good. We got 4 minutes left on this 3D print. Okay, so we can rotate that. Don't know how to actually make this bend, but the fact that I add this bend here is going to make it a little bit challenging, I guess. Constrain components. Oh, wait. Let me see what's kind of whack on this. Let's make that like 0.2 actually. There we go. Okay. There we go. That makes more sense now. So let's constrain this to this. And I believe since that was 0.75, 0.77 actually, because we added some spacing, -6.9, that's gonna be like 4, no, I guess 3? Huh. Did some mental math wrong. But anyway, can we actually constrain things tangent to face? I think we can. So we're just gonna have to like just kind of visualize it, I guess. Yeah, I mean, they won't really know if you're just doing like little one-off commissions, but once you're making like, I guess, engineering living money, that's kind of when they're able to take note of that. I mean, not advocating for it. It just kind of is what it is. You know, I don't think that's actually enough room here. I think we're gonna have to expand that more. Let's just make that 10mm just to be safe. And let's actually do a section analysis, I guess. Construct. Can we just pick a curve on here? Let's do a mid-plane one, actually. Yeah. Section analysis. I studied computer engineering, and most of what I do professionally is, like, programming related and stuff. But sometimes I'll do, like, robotics and other, like, multidisciplinary projects that, do need CAD and 3D printing. So that's how it kind of fits in my business stuff, I guess. Okay, so we can, I guess, just ignore the fact that that is hitting that, because that's really just supposed to kind of curve, and I don't know how to model that so it curves. I mean, I probably could look that up. How to warp a model in Fusion. Well, I mean, it's not really essential, it's just for visualizing stuff. But yeah, we have the molds finished now off the 3D printer. So let's actually switch to that and hope everything fits, because if not, we won't be able to do the molding today. And I know that this linkage stuff is not going to be, like, it's going to take several hours to print, so I'm not going to bother doing that right now, because I want to end the stream after doing the molding stuff. Yeah. So, let's get this stuff out of the way. And let's make sure that the mold actually fits together. So, I already 3D printed the center hub. Ooh, and that barely fits. Ugh, I might need to sand it a bit. That's okay. Oh yeah, that's gonna be, like, the perfect size. Okay, so let's just sand that down just a little bit. And it should fit, because it's, like, it's getting on, like, 2/3 of the way. So it just means that, like, something is just kind of catching. But that also means that we're gonna have a, yeah, there. Also means that we're gonna have a pretty good seal with, the Vitaflex and the petroleum jelly, which we're using for the mold release. But yeah, if you joined only kind of recently, before I was talking about the molding and stuff, basically, I've been working on this roller thingy and its mold and printing it, and while they were printing, I've been designing the rest of the mechanism. But now that's done, we can actually mold stuff, and we're using Vitaflex, which is a urethane compound that is very easy to work with, doesn't require any vacuum chamber like silicone. It's pretty non-toxic, like, you shouldn't drink it. And you should probably wear gloves while doing stuff with it, but, like, it's not gonna kill you, you can work with it at home. Don't need to do special stuff with temperatures. The ratio is 1:1. It has a 20-minute-ish pot life, I think. 15, 20 minutes, something like that. Pot life is how long you can work with it after stirring it and stuff before it becomes an issue and gets too hard, and it takes 1 day to dry, which is pretty easy. It's a very easy to work with material. So, yeah, if you want to make your own custom wheels and stuff like that, Vitaflex is fully what I recommend for that. It's stuck. Okay. So, it's sanded enough on that side. It's this other side that we need to sand a bit more. And it's really just to plug up the top part of it so that we don't get the urethane stuck inside the center, which would be really bad. And just tear that brim off. Okay, cool. So that is in there. That is in there. And then we just need to clamp it together with some screws. And then we have our mold. And then we can start mixing stuff. So let's go do that. Yeah, I can do basic Arduino shit, but that's it. I mean, you have to start somewhere. Arduino is always a good spot to start with. I'll still use Arduinos for some projects, although now I'm using like ESP32s and STM-based boards and other stuff. You know, I need to get some, oh, do I happen to have some here? I do. Perfect. I don't have to leave. Cool. Well, alright. I do have some, nitrile gloves. So we are going to do the molding now. Although first I need to calculate how much we actually need first, which is actually why I like to do that thing that I did earlier, where we took the mold and we took the hub and we basically made a negative of that. So this would be what it looked like if you molded it and then deleted the hub somehow. This would be the molded part alone. And with that, we can inspect it. Okay, how do I do this with, I know how to do it in SolidWorks. I don't know how to do it in Fusion. Okay. What's that? Okay, so 40.4, whatever that is. 2 ml. That's 40 milliliters. So we need, let's do about maybe 25 of each part. And just mix it up. Okay, I just want to do that before actually getting started on molding this, because I don't want to touch my computer or keyboard or whatever while working on this. Let me crack open another monster. Okay. Monster cracked open. Okay. I'm gonna go rotate the monitor over also. Okay. I do have an ESP32, but I did a bit broader engineering, so we get a project where a company comes with an issue and we have to do full design process up to a prototype, so we don't do that much programming. Yeah, there's lots of multidisciplinary parts of engineering, so I guess that one department will handle the programming and the other will do like the design and prototyping and stuff. Where is my molding kit? Well, that's a bunch of syringes. Bless me. Ah, here. Well, that's some of it. That's not all of it. I really need to reorganize this area underneath. What? That's where all my spare wheels were? I thought I lost all the spare wheels that I made. I could have just used those and stacked them. But oh well, I've been wanting to make a video on how to do this molding stuff anyway, so whatever. And molding's kind of fun. I find it to be kind of relaxing. Well, I found the scale that I use specifically for measuring this stuff. I might still need to get a cup. And, other stuff. I can't find my specific beaker thingy and whatever. I mean, I could just use my, yeah, I'm just gonna have to do that. Okay, let me go grab disposable cup and, some mixy thing real quick. Okay. I think my tracker's died. Let me put them back online. Come on, head tracker. There we go. Okay. Yeah, I need the trackers to work to be able to, automatically switch my cameras around when I move around the office and the workshop and stuff. Okay. So, let's see. That was, 40 milliliters-ish of stuff. So, first thing is, actually, I'm gonna do this without the gloves, because it's just petroleum jelly. I'm gonna paint the inside of the mold with some petroleum jelly. This will act as both mold release and a seal. So yeah, just gonna mold that in here. I think this is the most complicated mold that I've ever made, since most of them, which I've just taken out a bunch of them, most of the molds for my wheels are literally just this. Just a single piece, and I just pop it out. And this one I have to do in 3 pieces. Since it's like really funny shaped. But yeah, just gonna do that. On the bottom, we have this side pretty slicked up. Actually, I could definitely use more. Okay, cool. And then this other half, technically not half, more like a 3/8 or so. Oh, Ritsuko, sorry, that was a false positive and conversation.
No worries. I'll just be hanging out on the vertical display if you actually need me later. Catch you in a bit.
Cool, thank you. Yeah, that's the AI assistant I was talking about. She lives on my ceiling. And I wrote her. She's not OpenClaw. OpenClaw sucks. I realize I actually forgot to drill out some stuff here, but that's okay. You can just see that right now. Okay, let's see. Let's go with 3.5 millimeters. Just realized that I'm out of, what's it called? Compressed air. So I need to buy some before next stream, since there's some stuff I need to freeze while working with it to drill it out properly, but don't need it right now. Okay, so that's drilled out, and we can hit top of this with more of that. And then let's turn on the heat gun real quick. Technically the hot air station. Let's just set it to something lowish temp, just 100 degrees Celsius, I think. Because we just want to smooth out that petroleum jelly. But PLA deforms very easily. So this is just smoothing it out so that it molds a bit nicer. And doesn't really have, like, visible, like, paintbrush ridges. That area here has kind of a lot of, what's it called, petroleum jelly, so I'm just gonna wipe that off. And then the petroleum jelly is also going to help with, what's it called? It's also gonna help a bit with, oh yeah, keeping the urethane off of my fingers, even if I'm wearing gloves. Okay, there. And this still has some uneven lumps. So let's just thin that out. Okay, cool. So that should be decently sealed, I think. Yeah. Okay, so let's put this together now. And then I may secure it with a bit of hot glue just to make sure it's nice and tight. Let me go get my M4 screws. Oh, I think I already got them out somewhere. Where are my M4s? M4 is here. Alright, so 1, 2, 3, 4, 5, and 6. And 6 square nuts. 1, 2, 3, 4, 5, 6. Oh, I need to drill that out too. Okay. 4.5 millimeters. Here's the drill. Only need to do it on one side though. Well, actually probably both sides. Ah, damn, I just made a little hole in my new-ish mat. Oh well. I need to hit this again with the heat gun because I just touched it, so it's gonna leave like fingerprints. Okay. We'll just heat it with the heat gun again. Alright. Cool. Okay, now we should be able to close this. We could sand it. Yeah, let's sand it a bit. Where is my sandpaper? I'll just use a snail file. Okay. Although I'll probably have to reseal it with some petroleum jelly again. I know that there's going to be a little bit of dust in there, but I don't really care. I probably should have made this out of ABS, though, if I intended to sand it, but oh well. Okay, hopefully that's the last time I have to apply petroleum jelly to this. Okay, let's hit it again. Temps just a little bit. Okay. I think that's good. Let's see. Yeah, that looks like it's closing flat now. Okay, let's have this go crisscrossy. Those aren't long enough. Shit. These are too short. One, 2, 3. Don't want to use the black ones because I think they'll rust. Okay. Let's go with this. Length. Okay, so that's in there. That is in there. That is in there. And that is in there. And then we just need the last 2, and then we can crank up the tightness of that, and then we can just put on the bottom part of this mold, which I think probably still has a bit too much petroleum jelly, so let's reduce that a bit. Okay, now let's tighten that a bit more. I think my cat's trying to leave. JJ. Okay. Cat is let out. Okay, I actually forgot which screws I tightened already, so I'll just have to retighten them all again. That was at least one. Okay, that should all be tight enough now. And then where did I put that paper towel here? Okay, I'll just wipe off some of the excess from down in here. And then hit that again. A little bit of heat. Cool. And then this just needs M3. And let's make sure that this is like seated in there all the way. I guess you need to put some jelly down here also. Copious amount because we don't want this to leak in here because that's just be annoying. I'm not gonna worry about thinning that out. Yeah. Or you know what? Let's actually put a nice thick gooberish amount there. And then heat that up. And then that should be a really nice, good seal. Yeah, nice. Okay, and then my M3 countersunk screws. From there to the bottom of this. So at most 50. And that's fine because we don't have that many screws that are even close to that long. 3, 4, 5, 6, and they do not need to be exactly that long. Okay. Inserting that there. Oh, wow. That was not the clamping force that I expected. I was expecting more clamping force out of that, but that's okay. We can just seal it with glue. Although, if this is like anywhere slightly out of plane, or I guess slightly out of axis alignment, then it actually might still work. I think it'll still work, actually. But it's definitely fragile enough that I have to do this by hand. I don't think I can use drill. Okay. And I think this little top piece, I should probably just put a little bit of petroleum jelly around also, just so that does a thing. Doesn't touch the doesn't bond to the urethane. I mean, it's not gonna like truly chemically bond, but it's still gonna like be kind of sticky. polyurethane, not polyurethane, while putting petroleum jelly along that top bit. And then we can seal it up. And then we can start to fill the mold. And then I think the stream will be done for tonight after we do that. Oh, wow. Okay, so seal the top of this. And then just put some around here, and I'm not even gonna bother to like hit it with heat because this part doesn't even need to be smooth because it's the excess part. And then we can plop that in here. And yeah, I think I'm gonna just readjust this just a little bit since it looks like it's just slightly off alignment. Yeah. And we can probably use some clamps to fix that a bit. Yeah, we'll just use a couple clamps. Okay. Otherwise, it's gonna be a little bit weirdly kind of like oblong. I think I forgot to put like some, I'm not sure if keying features is the right word, but some kind of features to keep them lined up. But yeah, that's better now. Let's put those clamps back. Didn't realize how tight that space is, so I think that might actually want to use the syringes after all. It's a good thing I have so many just for this. 20 millimeters each, not millimeters, milliliters. It's a bit of a tight fit. How about you? Oh, I do have to be careful because that actually can bend, so have to make sure it stays centered after printing. Or not printing, after molding. Otherwise performance will get a little loopy. Okay, let's try to salvage this one. It's pretty easy to, if I have a thin enough thing to push it out with. Ooh, someone redeemed a water. Whee! Hi, Tyneck. Thanks for redeeming the hydrate. Okay, let's pull this out somehow. It is being difficult to push out. Wonder if I could just drill it out. Kind of like a corkscrew. Wow, it's almost midnight here. Bless me. My fingers are way too slippery to do that. Maybe we can go with like a smaller bit. Okay, let's try again. Oh yeah, I think that is, nope. Forceps. I probably ruined the air tightness of this with all that. Okay, I'm gonna give up on that syringe. I have more syringes anyway, I think. Yeah. Oh, I have ones with tighter holes, actually. That would be better for, injecting this stuff in there. So let's just use that. It's 12 milliliter, and it can go perfectly in there. So let's do that. Okay, well, this is almost ready. Let's just, hot goon gun it together. Just for the final seals. Which it's already pretty tight, and there's already, like, plenty of petroleum jelly, but it never hurts to seal it up a bit more. Do I have more sticks? Hot glue sticks, where are you? I don't feel like finding them. And it's just a little bit more, so I'll just push it out manually with this. This little seam here. Okay, cool. Now we can finally get to the VitaFlex part. Okay. So 25 milliliters of each half. And this needs to be shaken. Alexa, set timer for 5 minutes. Just shaking the VitaFlex. Needs to be mixed. Y'all want to ask me questions while I mix this? Because I'm literally doing nothing but shaking these bottles. And I guess moving some stuff around so I can sit down while doing that, because this is not the funnest thing to do while standing up. Whew. Doop, 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 doop. Doop, 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 doop. Alexa, time left my timer. Okay, I'm like 1/3 done with shaking this. Stirring this. Doop, 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 doop. Doop, doop. This part's boring. I am going to be coloring it with purple. Bless me. I should probably make a thing to, like, do this for me. Alexa, time left on my timer. Okay, I'm halfway there. And the method that I like to do, where I like use a syringe to draw it from the cup and then squeeze it in, that actually gets rid of a lot of air bubbles, because I guess it makes a little vacuum when you're drawing it through the syringe, and it's pretty cool. You can see the little bubbles just kind of being removed from it. Alexa, time left on my timer. Okay, I'm like 2/3 through. Whee! And the mold should be cool enough by now to not burn me with the hot glue. Oh, I should probably take this off of the filament. Okay, that's just a bit of brim. I thought that something melted or warped there, but I guess not. That's good. Okay. Should be done any second now. Okay, Alexa, stop. Alright. So, I think I do want to get a thing printing here, though, to kind of keep that center, since it's a little bit off. I don't like that. So, let's just get that design super quick. Top plug. Thinking is that we just have almost kind of like a spidery array of little legs that are 3D printed. Okay, so that's exactly 3 millimeters. And then by the time we mold the stuff, this should be ready to put in. And let's just hide all these bodies. I guess hide those bodies at least. And we can do a taper angle. Let's go with like maybe -5. Maybe -2. And we can make that like 20. -20. And then and then depending on how level this is, then we should see it. Yeah, so then we just jam this in until it stops, and when it's level, then that means that I think that each side should be kind of equal, I guess, in how much it's being shifted. JJ! My cat's here again. So yeah, we'll just get this started. just merge those bodies and get that printed. And that will probably take maybe 20 minutes at most, and by the time we're done with that, then we should have poured in all the stuff that we need to pour in anyway, so that should be done right on time. Just checking, that is, yeah, 1.5. Where's... oh, it's on the other screen. Okay. Wow, 10 minutes. Perfect. Okay, cool. So yeah, let's just get that printed, and then we can start mixing up the Vital Flex and molding it and stuff, and then we should be ready to pull that off. Okay, I guess I can take my gloves. And I'm just gonna lock the camera on the workbench view. Whee! Okay. We are locked on workbench view. And let me just raise this up here so it's kind of out of the way. Yeah. That should be good. Okay. There's too much glare. I can barely read that screen with this thing on. Okay, if I cover it up, that's not bad. Okay. So let's peel this shit off. Already making a mess. I wonder when they switched to foil seals, because I could have sworn that this used to use like a papery seal. Not complaining though. Okay. So let's see. We're at 0. Okay, let's set that to 0. Let's pour in 25 of this stuff. We're at 20. 24. Okay, we're at 25 grams of this stuff. Oh, right. I'm gonna use my argon for the first time to keep this stuff preserved. If I can even take out the straw from it. Okay. Straw does not want to stay. So this is argon, and it should keep it preserved. So. Cool. So that is what? 25.1 grams. Just tapping it a little bit so that I can keep the thingy active. And we're gonna put maybe just like 1 gram of powder in here. Honestly, I think probably just half a gram is maybe all we need. Okay, awesome. And let's put another 25 in here. Cool. And then put a bit of argon in this. And we can stir this up. Alexa, set timer for 5 minutes. I wish I had my, like, silicone stirry spatula thing and the silicone, what's it called, beaker-ish thing that I use to stir this stuff. Because, it really lets me get, like, all the little corners and stuff, and they're, like, it's part of a kit, so they're, like, the exact same size for each other. But, yeah. This just needs to stir for, like, 5-ish minutes. And then we pour it in the mold, and then we are probably good very soon. Pot life of this stuff is something like 15, 20-ish minutes, so that's plenty of time, and not doing a whole batch of tires, or just doing a single roller. Alexa, time left on the timer. Alexa, time left on the timer? Okay, we're like a third through. I'm gonna sit down a bit. And the hub is already like 5 minutes away, so we're gonna be like barely starting to pour this stuff in, and the print's already gonna be done. So that's perfect timing. Swirly, 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 swirly. Let's keep mixing this stuff together. Let's get all the sides in. I want this to be very even. And is this the color that I want, or do I need more purple? I think I could use a bit more purple. Makeup powder is kind of inert-ish, so you can put quite a bit in there and it's not gonna mess things up, really. Yeah, that's a deep metallic-ish purple that I like. This is how I make all my robot wheels, by the way. Alexa, time left on the timer? Okay, we're 2/3 of the way in-ish. Mixing stuffs. There we go. Alexa, stop. Okay, we have mixed it enough, and we can finally start to pour it in. And we have like 2 minutes left on the print, so that's perfect timing. Alright. So, yeah. I have 48 milliliters of this stuff. And if you can see that, okay, this might need to be snipped a little bit because it's taking forever to load up. Yeah, let's snip that tip a little. There's some scissors. Okay. How about now? Oh yeah. You can see that bubbling up action. I'm gonna do it again because it's really fun to watch. But with a close-up. Yeah, that's all the air bubbles being vacuumed out from the vacuum created by the syringe. That's pretty neat. And then I'm gonna get my chair over so that I can sit down and be a bit more precise with this. Okay. So I've mixed together about 50 milliliters. So that means that we should be using up about 80% of this before it's actually totally filled up. So that's kind of how I guess we'll know that we've completely filled it up. And that does include all of the retaining features also. So yeah, that means about probably 5-ish injections of this stuff should be about the full thing. And we're at 3 already. So we're probably gonna have to wait a little bit for stuff to settle in to all those retaining features, for all the air pockets that are not part of the air bubbles inside the stuff as you draw it. And that print just finished. Alright. So we're probably close to having that last draw's worth in there. With like some kind of like massager or something. I don't think I've ever done a mold quite this deep before. Might extract some bits out of it. Yeah, a vacuum chamber would have probably been a little bit better for this, but it's okay. This doesn't need to be, like, super precise. And if it doesn't work, we can just remold it again. But I think it'll work. Alright, well, I think that is as much as it'll go in there, and I think we used up the right amount of urethane for this. And it doesn't look like anything's leaking out, so that's good. I don't see any more air bubbles rising out of this. So yeah, I think we can take off the gloves and get that little 3D printed spidery thing and get it in place. And this should keep the hub centered. Let's turn up the heat just a little bit so that we can get these like little threads off. Not so much off, but just more so like cleaned up a bit. Might look a little funny, but that's okay. I mean, we do have a little bit of time to work with, so I can just like quickly file down those funny ends. Ooh, something already broke off a little. Yeah, let's just trim that so it's like all kind of evenish. Okay. And then if we stick this in here, should... Wow. It's actually kind of like Zally lined. Okay. Well, we'll just go with this. Let me just snap off little bits as they come in. Or, you know, actually, if I can get that out, which is gonna be a little hard, but I do have tweezers. Well, no, it's already covered in the urethane, so it's not gonna help. Okay, yeah, we'll just leave it like this. Okay, cool. Well, that is now molded, or molding. It'll take 24 hours, but yeah. Okay. Oh, did my stream die for like... Damn, I think my stream died for like a couple minutes or something. Oh, wow. Okay, well, I think this is gonna be the end of the stream. I need to wash my hands anyway. But yeah, we did almost 5 hours. I think we made some good progress. I'm gonna go get the rest of the mechanism printing, and then hopefully on Sunday we can assemble everything. Or, I mean, I'll be doing some pre-assembly so that we're not wasting time doing reprints and adjustments. And then I think Sunday we can just assemble everything, and do testing and get the programming working. But, yeah. Or no, today's Tuesday, so that means I can do that on Thursday. Yeah, I'll do that. Wait, what is today? Is today Tuesday or is today Thursday? Today is Tuesday, so yeah, Thursday should be able to start to get that ready, and then that means that we can probably wrap the Cradle of Pilth by Sunday, which would be great, because I think that's when my new medicine regimen starts anyway. But yeah. Okay, well, I think I'm gonna be logging off now. Yeah, thanks for tuning in. Let me go find someone to raid, actually, on Twitch. And then we'll raid them, and then, let's go with snacks. Okay. Cool. Alright, well, Generate snacks. Okay, how does rating fucking work? Because, like... It says, like, invalid channel name. Okay, how do I do a raid message? I need to learn how to do this. I don't get it, though, because whenever I put, like, the message in there, it'll say, oh, that's an invalid message, or that's an invalid name with the message. Whatever, no raid message. Okay, cool. Alright. Okay, well, I'll see y'all. Thanks for tuning in.